Okay, hello guys. It's nice to see you. And uh, we have very difficult schedule today because there are lots of cool projects, and it would be great if you will give a short talk about them and describe what are you going to do, and so your data and further steps. I guess we will start with the schedule published at our Google Doc page, and it would be great if next speaker will prepare while the previous one is talking. The first one are Nikita Fedyashin and Polina Karpikova. I can see that Polina is here and Nikita is also here. So are you ready to start?
Yes, we do. One moment. Can you see the screen?
Yeah, great.
Yeah, you can see it, yes?
Yeah. And I guess the others can see it also.
Okay, we'll try to be fast. So our project is implementing Iceland's and the main path approach algorithm, and members of our team is me and Nikita Fedyashin and Polina Karpikova. This is our useful links. Probably we'll send it in our chat later. The first one is GitHub, and the second one is Telegram chat, as I understood connection link properly. So this is our small description. We are going to implement two algorithms in Python 3.
It would be great if you give other students the idea of the islands algorithm, just why it's useful and what is your main goal. Yeah, because it's not just the control point, but also some education process for others to understand what can be done with social networks. So can you give a short description, okay?
So this is probably the main idea of these algorithms on the slide. The first one allows us to detect subgraphs to communities in the graph using some numerical feature, effect function. It's easy to understand how this algorithm works with analogy to its name, Iceland's algorithm. So you can imagine some place with a lot of islands, and imagine that we are starting this line, the world's ocean line, and we'll start seeing new parts of Earth, of stone, while ocean will be becoming lower and lower. So some islands will start to connect between each other. So the main idea of this algorithm is to find a lot of small islands, and after it start decreasing ocean level, and at some moment find good communities inside the graph. Another one is main path approach. It's based on calculating special coefficients, NPPC, SPC, SPP. The main, good part of article is calculating these coefficients fast and applying them to find these main paths. Again, idea is to just choose a node, and after it choose a path to another node according to these coefficients. And this algorithm also allows us to find some structure. For example, in graph of citates between scientists, we can find the main topics in this graph. Also, as I saw in article about main path, authors used it in combination with Iceland's to analyze. So they divided the graph into Iceland's and applied main path approach to analyze it. This is our steps. We already chose a data set and found like a description, main properties of it. So our next steps is implement Iceland's and main path algorithms, then apply it to our data set, and probably we'll try to apply it to different data sets, because so if you implement algorithms, it will be probably not so hard to implement it to different data sets. About roles, it's a very technical project, so we're both doing programming, and for now we decided that I'll be more concentrated on Iceland's algorithm and Palina on main path approach, but probably it will be some mixture, as I think. And for now we chose Twitter dataset. So on the right part of the slide, you can see some statistics. It was created in another research where authors were analyzing EGA networks of users of Twitter, but we're going to use it just to verify our algorithms. Yes, that's it for now, and probably we'll choose another one data set. Yeah, and I have to send the links in our Telegram channel. Yes.
It will be okay if you all if all of you will create some kind of README page and put all the information about data sets. And
we have it on GitHub.
Yeah, that's great. That will be enough. A few ideas. So first of all, yeah, everything is correct. So you can think of these islands as some threshold inside the agglomerative clustering. Yeah, there are some similarities between them. And the problem is that I have not found any proper implementation of both of these approaches. They sound pretty prohibiting, but as I know, the only implementation that exists in R, where Vlada Blatagel just coded it, and in R and Project, yeah. So that's a real problem. My first question is about your algorithms. Are you going to implement it on some computationally efficient language like C++ or something like this, or it will be Python?
To be honest, probably both of us are more about Python than about efficient languages like C and C++. So for now, we're planning to try to do it on Python.
Okay, just that would be also fine, but in this case, I guess you should use some kind of efficient computation functions from SciPy, NumPy, and so on in your code more often, just to make it a bit quicker. Because one of the most one of the great features of both approaches is that they're very, very quick, and it's really hard to make something quick in Python. Yeah, you have only one control thread, and you need to. So there are lots of problems with concurrency and with efficient memory operations inside Python. So if you will find some strengths in your team to implement it in C, it would be much more useful and cool. Yeah, but so it wasn't the condition of the project. I guess any implementation would be good. So that was just some kind of idea that could be found useful. The second one is exactly about your data set. In fact, implementing algorithms doesn't really concern data sets because yeah, they can be applied to any source, but I guess Twitter in this case seems not the good one. It would be really hard to give some interpretation from the Twitter data set, and I guess the best thing that you can do is just pick something like core data set of published articles and try to adopt your algorithm to the core data set or one of the data sets used by Vlada, because in this case you can compare his results with your own to be sure that everything is implemented properly. So here are several ideas how to change your data set. Core is available everywhere. There are 2 links inside our datasets page of our GitHub repository, and I guess other datasets are also publicly available. Yeah, okay.
Yes, okay, thank you. We like overviewed one of datasets from the article, so we'll probably try to move to this one. Thank you.
Because the main goal here is just to be sure that it does the same as what was designed by author, and the simplest way to check it is just to evaluate the results on the similar data set. Okay, so
thanks.
Super, and I guess we can move on. Yeah, by the way, one more announcement. Guys, can you please open the grades tab of our spreadsheet and add your GitHub nicks to this tab. I have created this column just to, it would be easier for me to add you to some workspaces and so on. It's really late to ask for this, but I guess it can still be possible. Okay, so no one decided to take this world marine trade analysis. That's a bit pity because it's a very hot topic according to the current processes of some economics fracture. Yeah, and lots of trade routes are being changed right now, but okay. But we have one person decided to pick the project about communication structure. So, Christina, are you here?
Yes, I'm here, but it would be nice if you put me at the end of the queue.
Okay, if the rest, if you are ready, for example, so Yuri and Artemi, are you with us?
Yes.
Okay, let's start.
Wait a second. My deepest apologies, but how do you share the screen? Somehow never did it in Zoom.
It would be hard to describe it. There is the big green button at the bottom of your screen.
My apologies, never noticed it.
Okay. Oh, that's great.
My screen is visible, right?
Yeah. Super.
Great. Well, the project is about voting blocks or coalitions in the United States, United Nations. And it is known there are official blocks in the General Assembly, such as consisting of certain African countries or East Asians and so on. And then there are actual votings done, which may lead to surprising connections. The aim of projects is such to check the relatively modern voting records in the main organ of the United States and the General Assembly, and to describe the voting distribution. So far as it is concerned, the following was done. I have scraped the voting records of the United Nations General Assembly from the start of 2007 to the current day. The reason for that is because it is the first year when Yugoslavia has stopped existing.
You're a cheater. Okay.
Aspect shows it was justified. And if needed, the search engine at United Nations Digital Library allowed me to filter the result by certain categories, if need be. Then I used voting records to build a complete graph that shows how likely one country is to agree with now, using a very unintuitive metric. Namely, I took the logarithm of proportion of times and certain countries disagreed in this vote. Namely, should one country voted yes, I considered amount of times this country voted no and vice versa. And ignored the times and a country abstained or was absent as a vote.
Okay.
The following graph, as I mentioned, is complete. So judging the normal degrees, degrees in height and geometry is pointless because it will be trivial, at least for now. But because edges have a certain meaning as a summative probability, one can use such metric as weighted degree, namely the sum of weights of all edges going out of the node, which allows to judge the country is more or less conformist, namely how likely it is to disagree with everyone else. This metric proved to be very close to estimates of infected centralities, both the PageRank and the one president for kicks. Namely, the similarity is such that if we visualize it, it's identical.
Yeah, because weight degrees require some kind of filtering. Yeah, you still need to remove this super dense structure. Yeah.
Yes.
Mm-hmm.
But to be honest, the current picture already shows a few big voting blocks in UN. Namely, the ones do their own thing, they're painted blue. The ones that conform to everyone else, it's a bunch of smaller dots.
Mm-hmm.
And someone in between are the green dots, which includes countries that pretend to be different.
So look, okay, so please finish your talk and I'll give some comments.
Oh, it's basically over. The rest is information on who does what and the repository.
Okay, super. Guys, by the way, I'm not the only guy who asks questions and gives some ideas, so you're welcome to participate in our small debate. So if you have questions, just unmute yourself and ask them. So several ideas here. It looks hard to legitimatize the current edging function, the third slide. Yeah, because it sounds pretty smart from one point. From the other points, we cannot say why exactly this. And maybe it would be also useful to check something like correlation between two countries that should be very, very, very close to your first line, but will give you a bit different result. And maybe playing with weighting function will lead to a bit different pictures, and discussing those differences will show some. Will show something. This is the first idea. The second idea is that it looks like your project is just created for something like graph attention networks, because finding coalitions is great, but generally the thing that we would like to model is something like the some case of power of the country, because so if other countries are oftenly being coalitioned with this country, it is really powerful. Yeah, in terms of soft or hard power, they're either frightened to this country or highly dependent on this country, or really agree with this in terms of cultural and other factors. This is especially interesting in current cases that happen right today. But anyway, so you can take some external features like some coefficients, like size of economy, some metric, some features, and try to predict those features from the network structure. And that would be really interesting, because in some cases it will highly correlate, in other cases it will not. So you can try to predict some external feature with the network structure using graph attention networks. Yeah, this could be an interesting result, the final result of your project. The second interesting result is just to try to see if there are some countries that have changed their coalitions and who has switched to the other cluster. If you make several slices moving through years, you may find that maybe some countries something has changed for some countries. Yeah. And another question here is, so I would really be interested in your scraper, but generally when I did this analysis, there were lots of problems with extracting final decisions done by different countries and with names of different countries. So I know why you have picked the date after Yugoslavia has broken, because if you start from the very beginning of the United Nations, which looks more kind of interesting research, there are lots of problems with data curation, where one country was called this way and then it started to be called another way, and so on.
Oh, there are problems even with that side with this.
Yeah, and so I guess that's fine for the cost project, but if you want to make some kind of full high quality research, it would be better to take the data from the very beginning, because it will be more kind of depth research. Yeah, but generally it's quite okay to take this period of time. So I'm really happy that you thought about those naming problems. So my main idea is that you can try to see if there are some block movements, and if you can predict some extra network feature with the current network structure, yeah, and find some ideas behind it. Some economic and cultural weights can be easily found at different World Bank statistics, for example, and you can map them with the countries and see if there are some correlations, and if you can model those kind of features with that. Okay.
Yes, thank you.
Great. Let's move on. The next one is maybe it would be better if I will just post what project is going to be described now, and it would be easier to track what's happening for all the rest of you. So Daria, Richard, and Anna about the COVID. Okay.
Thanks a lot. So can you see the presentation? It's okay. So now, our topic is devoted to the propagation of COVID-19 conspiracy theories on social networks based on VK of Contacte. And our team includes 3 members, me, Anna Brevich, Daria Grishina, and Richard. So let's move, sorry, I'm so sorry. Here you can see some links for communication with us. We have prepared our project repository and Telegram channel, and one more additional way to communicate with us is Yandex Code, for example. And how I said before, as I said before, here are members and our roles. So my role, I don't know, sounds like team captain or project manager, I don't know. And my main tasks are about communication, planning, presentation creation, and data description. So Dasha stands for uploading data set, creation of research plan, determining clustering criteria, and she is the main idea inspirer. And Richard is kind of visualizer, and he stands for data processing and description, chatting, and data clustering assistance to Dasha.
Yeah, now let me tell you a small introduction to our project. Like, we have some hypotheses, and the main idea is to investigate the propagation of conspiracy theories from user to user and from groups to users. Like, we want to understand how conspiracy theories are formed, and like whether they are formed in VK or somewhere else, and to find the mechanism, how they are spread. Like, is it a snowball made from different comments, or is it more centralized? And we want to understand who is the main actor of distribution of this series. You can skip the next slide. Yeah, a bit about our goal and steps of the project. We conducted analysis of literature already. We came up with some hypotheses, and now we are working on how to cluster our data and thinking about the algorithm. Then we will cluster it and try to build on this basis some kind of network. And then Richard will visualize everything, and he will tell you about our data now.
I guess, sorry guys, I have been a bit familiar with this project. We have talked already during our consulting hours. So as I remember, the problem with these, not kind of problem, but the specifics of this project is that lots of posts are being published by users by different entities of the social network actors. Yeah, they can be groups, they can be just single users. So have you decided, are you going to analyze all of them with some weighting strategy, or you will focus only on one small group?
We haven't decided yet. We are thinking about it, but for now, it's more likely that we will analyze only people without groups, like people comments.
That would be really hard, because if we are talking about Russian social networks like Contacte, it looks like groups are main content distributors, and it would be hard to see who started something without the main power of this information cascades. Yeah, so in this case, it's a bit risky in terms of your final results. I'm pretty sure that you will try to do your best with your code, but the project may fail just because you're not analyzing the main spreaders of information. So be careful with this.
Okay, thank you. Yeah, maybe we shouldn't make it more difficult ourselves.
Okay, so please continue. Sorry for disturbing.
Okay, we thank you for your contribution. So you will pay heed to what you said. Now I want to describe our data so far. So we have 37,685 messages, and then 23 anti-vexes groups on VK, and then so far 24 clusters, and we have some small graphs which ranges from the period of October 1st to December 18th, that was 2021. So you can move to the next slide. So with the descriptive statistics of our data, first we concentrate on the number of messages. So with the number of messages, we were able to find the mean message, the standard error, the median, the mode, and all the statistics that describe the data. So that's fine, and that can be seen on the left side of the slide, and a small graph that represents the data concerning the number of messages. So there's also some graphs that shows number of subscribers, some graph of views, SM index, and engagements. So basically this is what we are about to do, and something small that we've been able to do so far.
Yes,
So,
and okay, yes.
Am I right that you're still going to scrape the information about the group users and the user friends, and it's still not done?
There is already some information, not on their friends, but like some information about how old are they and what groups they usually post. But yeah, we haven't done anything about their connections with friends.
And the only source of data, so you're going to analyze only data from the Contacte. Yeah, so there's only one source.
Yeah, right.
Okay, so in fact, Contacte gives you lots of possibilities to download this data. I guess you will not have problems because how many actors do you have in your network of 30,000 comments?
There are 9,008 actors.
Okay, so I guess you can download this data for a day, but so it won't be hard, but then you will need to download the information about their surroundings also, and this may be a bit long, so you should start doing it as quickly as possible. And are you going to use something like inf2back to model the propagation of these fake theories? Or you're going to stop only at descriptive statistics of your community structure?
Probably if we can, we will go deeper, but for now we are thinking of just descriptive.
I really highly motivate you to add the block about modeling the information propagation here, either with some simple strategies like SI or SIR strategies, because I don't know either these are some kind of rumors or fake news spreading, or this is a tendency, and if someone starts to think about the world's government, it's some kind of trend. So I guess it's more likely to be a trend, and you can at least try the model of the threshold model. and see if it really describes the process of this trend spreading. Yeah, it won't be difficult, but you can still try to see if your model and your current graph model can suits your data. It would be really interesting, and this looks like some final point. If you will only do the community detection structure, it looks like your research and your project is stopped at the mid of the research, because, okay, those groups look the following. So what can we get from this? Maybe you're right, maybe you're not. So you need to prove that your group structure is useful, that it models something, that it gives some insights. Yeah, and this can be done with some kind of propagation modeling. The simple one is the threshold model. The complex one is something like InftoVec or graph attention-based mechanisms. Okay.
Yeah. Okay. Thank you.
Okay. So please include it to your project plan. Okay. Any other questions, or we can move to the next one? And the next one is the project about cryptocurrency trends and how they affect each other. So, Anastasia, Nikita, you're welcome.
Yeah, thank you. 1 minute. Can you see the presentation?
Yeah, great.
Okay. So first I want to discuss a little bit the paper and the motivation of our work, and then I can actually show the visualization and the work that we've already done. So right now I would like to introduce the paper that was published in New Reefs in 21. This is a deep learning conference, a major one of the major one, and it focuses on applying graph neural networks to time-series forecasting, multivariate time-series forecasting. Why? The first question: why do we even apply graph methods to financial data? Numerous research show that graph-based methods are actually quite useful to financial data because they can capture the correlation structure in those type of data. And actually capturing correlation in financial data is one of the most important types of hidden relationships that you want to find, because further you can use it to forecast volatility or base your portfolio construction on the metric. And why this particular paper stands out is because it uses both inter and intra-series correlations. It means that since we have a multivariate time series, so basically we have, for example, n by t metrics, where n is the number of time series and t is our length of period. Basically, it can capture data between time series and inside the particular series. So, for example, autocorrelation and etc. Also, this paper directly converts the price series data to graph data structure, which is quite impressive, because some other methods use converting price series to correlation matrices, and the correlation matrices are then used as the inputs to some models. This is suboptimal because computing correlation matrices is quite time-consuming. And this particular paper uses the method based on the transformer architecture, which also finds it. It is also found that the transformer architecture is beneficial for time series data. And finally, this paper presents a versatile framework for multivariate time series forecasting, and can be the inner workings can be adapted, modified by, for example, other works related to graph neural networks. Now a little bit motivation, not motivation, but how the paper works. Basically, as I said, we have n by t matrix X. The paper firstly converts this matrix X into a pair, X and W, where W is the adjacency matrix. One of the advantages of the approach introduced in the paper is that constructing the adjacency matrix takes, it can be said, little time, because here you can see it is n squared by d, but n is usually, for example, can be 100, and this is not a very large number to compute. And then the paper actually does the inter and intra-series analysis. It has some complicated approach, so I don't present it. Regarding the data, data we used from Kaggle, I will show this data here. It is around 400 cryptocurrencies sampled at 1 minute resolution. We use this type of data because it provides a large number, it provides a large data set. So basically we can train a model on 100,000 timestamps. And this is quite good. This is good for deep learning methods. The structure of the data is the standard. It has a timestamp, and the information on the price dynamics during the minute. Now, what we have done. What we have done, we already done the data processing pipeline. So we download and process and visualize data. We analyze the correlation structure between multiple pairs. Now we use not all 400, but significantly less, because we have some challenges in aligning the timestamps between different pairs, because, for example, some pairs were sampled during the day, some were not, and this introduces a challenge for aligning those timestamps. So we also adapted and trained the model for our data, and conducted the inference for our data, and obtained some network topology metrics. I can show it after the presentation. And the next steps and challenges to solve, as I already said, we need to try aligning timestamps to increase the number of pairs that we use for our model, because actually the purpose of all the using graph neural networks for time series data, financial time series, is to have as many as possible dynamics of currencies, and try capturing some latent structure between them. And finally, we will evaluate the results of the paper, that is the quality of forecasts on our data set. But we not only focus on just applying the results of the paper, we also want to extract some features from the model to further formulate a particular trading strategy. For example, dynamically select a portfolio based on some other algorithm, and combined with the features obtained from the model. And regarding the metrics that we already computed, we computed closeness centrality, between centrality and page rank degree centrality. Yes, we also have this is the network of some currency pairs. It's present here. So basically, it's over. I can I can answer questions.
Generally, guys, so it looks like you know what you're doing and you're doing well. So I guess this is one of the most ambitious projects, the whole course that I have seen, because it really adopts something like the cutting edge papers, and everything looks pretty cool to me. So you're moving well and you know what you're doing. Generally, I have already sent you one paper that I was interested in when I was just looking about this topic, yeah, and maybe you'll find it useful just to steal several ideas about these grouping factors from traditional stock markets, because maybe there is some grouping behind the cryptocurrencies also, but generally, so everything looks fine. Maybe further outside our course, it would be great to try to adopt this model just to some traditional financial markets, especially some kind of not popular stocks like I don't know, Amazon and so on, yeah, because a lot of people that are not interested in cryptocurrencies are interested how different small companies are connected with each other and being affected with each other, yeah, and sometimes so lots of guys would be very interested in the model that will work well for traditional markets. But I guess all those ideas are outside the course, and so the things looks very interesting. Yeah. So except the thing that everything is connected to everything here, and we need to filter this connectivity somehow. But maybe these are just bad pictures, and the model will learn everything from the connection weights. Yeah.
Yeah, I have a question also. For example, in this particular stuff where everything is connected to everything, should we, for example, filter it by using minimum spanning tree? Is it applicable?
I'm not sure that this is the good filtering strategy. I don't think that this is the good criteria in this case, yeah, because
I just thought that the intuition behind minimum spanning trees that we filter out edges based on the minimization of total distances between any node. So in the cryptocurrency intuition, it will be we try to minimize some kind of correlation distance between any pairs, so that is if we can reach, if one pair is quite correlated to the other, we will retain those important edges and reuse those.
Yeah, I understand, but you know, it looks like minimum spanning tree is too dummy, and it will just filter the. Okay, so in fact, maybe you can try it, but generally, I'd rather start. In fact, this is something really good for this islands approach that guys from the first group are being implemented. Yeah, it looks like it will give you more accurate results rather than minimum spanning trees. It looks like your idea can work, but it's a bit rude for this data. But
I
so
see.
this can be discussed. And if guys that are implementing the islands approach will be quick, you can try to use it for this data and see what islands would be created here. Yeah, and it would give you some kind of better filtering strategy. But there is no right answer because it's some kind of research. Yeah,
I understand.
no one knows what will work. Okay, so sorry, but this is really very kind of unsupervised topic. Yeah, and I cannot give you some silver bullet. Anyway, so as I told, you're doing well. So you have analyzed the data, you have filtered it. So everything is okay in terms of the course progress.
Thank you.
And you're welcome, or in fact, all of you are welcome to join some consulting hours and to discuss it in more depth, because at the consulting hours, we have more time to think about some hypotheses. Yeah? So we may just move there. Okay, the next guys are about the movie. In fact, the topic sounds like analyzing the quality of the product, but from the paper description, I understood that the product is the movie, so I have labeled it as some MDB. If I'm wrong, please correct me, but so Victor and
yes,
guys, you're welcome.
Well, actually, the product is auto, so we want to improve the quality of an auto. This is the product we'll be dealing with. Yes.
So because I'm pretty sure that when I was reading your proposal, there were no autos. No, I'm wrong.
Maybe when we sent the proposal, we told about movies because this was actually an option, but then we changed. Then maybe yes, you are right, I guess.
Okay, so then you can.
But
just,
the idea is essentially the same. Okay, well, guys, don't worry because I am not going to show the whole notebook. I am just going to go through the key points of the notebooks. Can you see my screen?
Yeah.
Yes.
Okay. Well, so the idea of the project is to show how to improve the quality of a product via network analysis and natural language processing. And well, this project is going to be pretty varied as we use machine learning neural networks, a lot of natural language processing for the pre-processing of the reviews and so on, and in order to extract meaningful data, which is trainable and can be represented in a network. And of course, we are going to use social network analysis. So what we are going to do first is to train a model to predict a sentiment and a rating of a product based on its pre-processed reviews. The product is going to be, as I said before, hotel reviews that we extracted from TripAdvisor. This is a database containing 20,000 reviews labeled from 1 to 5. And then in the next step, what we are going to do is to use social network analysis in order to extract features that make a product, in this case, the hotel, good or bad. And why we do this? This is because if we only conduct sentiment analysis, we don't have information about why the product is good or bad, or what is making the product good or bad. But if we mix this with social network analysis, we can access to those characteristics asserting the quality of a product. And then we can use them to improve the product. So what we will do in that further step is we suppose we add some modifications to our product according to the good, bad, or insignificant features that we have extracted from the network analysis and assert all these intuitions that we had based on the neural networks models that we have created. So in the first step for the data pre-processing, we had to clean every review. And cleaning every review, here I have created an example here. Cleaning every review means tokenize. Tokenize is just dividing every review in single entries. So it will be a list of words. then we are interested in delete alphanumeric values, and also interested in deleting stop words. Stop words are words that are not very meaningful, so they will not provide a lot of information for training or in the network itself. And then last step in pre-processing of all the reviews, it is the so-called stemming of the words. This is just to get the root of the word, because finally in our network, every word will be a node in the network. And then we are not interested in having 3 different nodes, for example, for interest, interesting, and something similar. So we are interested in only having the root. This is a way to reduce the quantity of nodes that we will have in our network. So that's it. Then for every, so here you have an example. For example, if we introduce this message, this is a really nice and interesting project. What do you think? We obtain the most important information about the message. So, and also we delete alphanumeric values and so on. So this will happen to every review, and then we will apply some sort of one-hot encoding to train the model and to create the network. And yes, in this way, I don't want to go deeper into this because, well, we don't have a lot of time. And yes, we create a vocabulary, and the way the vocabulary is created is we measure the frequency here. Sorry, we measure the number of appearance of every word, and then they will be labeled according to the number of appearances. So then the word with most appearances will be labeled with the vocabulary ID 0. And so on. So this is great because when we want to do some data reduction for the network or for training the models, we can just delete the last columns because we know that they are meaningless as they are not very frequent. Yes, they don't contain some very strong information about messages. So that's it. We create matrices, and as for the neural networks, to predict the rating and sentiment, we have chosen PyTorch models, and actually we obtain very good results because, for example, for the sentiment, we obtain an accuracy of 82 on the test set that we create. So test set is just 2,000 reviews, and for the rating, because, well, this is way more difficult, we actually obtain very nice accuracy. There are 4 different labels, and we obtain 70% accuracy. So we are very happy with this. Well, we created confusion matrices and so on. And now my colleague Jesus Ariel is going to discuss the creation of the network.
Yeah, okay, so for the network, first, we realized that the graph was really dense. So to speak, each node has so much edges interconnected. So to avoid this problem...
Wait, guys, stop. Just once again, we had a pretty good lecture about natural language processing, but generally, so we have reviews of different portals, yeah? And how are you going to create the network from this review structure, or what is the source? What an edge is going to be, and what a node? Node is a portal.
Yes, nodes are going to be words, and
words.
edges. Yes, yes.
Okay.
Stem words, like the root of words. Yes.
Yeah. Now I got it. So you want to build the network of words given the
I can show
of the reviews. Okay,
that's it. And well, Jesus, you can talk over here if you want, or I can show the requirements for the edges.
Sorry, you can continue. My question was to Ariel, because I haven't got where the network has appeared, and he started talking that the network is very dense.
Yeah. The nodes are going to be the words, and based on the frequency, And the ideas, first of all, we believe that the relation or the edge was going to be if two words has the same rating. I mean, we have 4 ratings, 1, 2, 3, and 4. So if each word has the same rating, we are going to draw an edge between each other. But we realized that the graph was going to be really dense, was going to be really interconnected. So because of this, we put 3 requirements for the edges, and the requirements are the following. If the words has almost the same frequency, it means that if the first 5 words has the same frequency, we are going to interconnect it. We are changing this value to see the output of the graph. So in the first requirement, we put a threshold of 5. So that means if the difference between the first word and if the index of the first word and the index of another word is less than 5, we are going to interconnect them. And the other 2 requirements are at least they have to share a minimum of 10 reviews and a maximum of 18 reviews. So if the words have these 3 requirements, we are going to draw an edge between each other. So
may I say something? So the reason to do this is to split the network into smaller pieces. Then we vary all these parameters that are setting requirements on the network that are setting these smaller pieces, and then via understanding the smaller pieces have a general understanding of the whole network. Because if we don't segment the network in this way, it is very difficult to visualize, and it is very difficult to understand what is going on. That's it. And
it was so difficult. Actually, we draw the network, and it was really dense.
And this is the kind of network we obtain with those requirements. And you can talk also about we have computed the centralities, and the size of the nodes are directly proportional to the centralities. So for example, greater nodes correspond to greater centralities, and also for the all the others.
We just draw, we draw for centralities, degree centrality, also eigenvector centrality, also closeness centrality, and the other one, betweenness centrality. And yeah, as Victor mentioned, we plot the centralities based on the value. So after that, we check the values of the centralities and make a table to compare the results. And we got that those are the most important nodes based on the centrality. And for instance, in degree centrality, we got that the most important node or word is expense.
Which is the root for expensive. That's it. So it looks like we are going through the right path in our analysis. Also, we can find noisy over here. This is the root for noisy. Also, we can find coffee as a very important word. So I think we are going to obtain very interesting results. So we will keep on studying the network in this way. So
okay, guys.
That's it.
I guess all the others are a bit brain dead, but generally, my most important question here is that your original topic was improving the quality of the product. And where the improving starts?
Yes, once we collect the characteristics that are making a hotel good, bad, or so on, we will check our intuition based on the neural networks that we have constructed. Yes, we don't want to say, okay, we think it is like this, and that's all. So we are going to test this on the neural networks that we have constructed and trained. That's it. So it is, well, of course, if you do only sentiment analysis, it is impossible to know what's making your product good or bad. But if you kind of represent all the data in a social network and you interpret all this data, you can have an idea of what's making the product good or bad. So it is like you have a sentiment predictor, and then you also know what is determining the sentiment, let's say. And this we test via the neural network machine learning model that we have created.
Okay,
it was pretty fast. But...
yeah, and maybe too long still. It looks like we're out of time. So generally, you know, I'll try to be short because I have lots of comments about it, but I guess everyone will just die if we start discussing. Yeah, generally, this looks like some kind of wild research of guys that have just broke down to NLP and started inventing things. And there is just plenty of methods that at least should be compared. First of all the same stuff can be done with the metrics factorization tools. Secondary, if you do not want to use some kind of statistical models, there is the perfect area of black box model description that gives you nearly similar results. Yeah, and if you are proposing some new method to describe your model or to find what the importance, it's just somewhere very close by. You need to reference the other ways to do it. Yeah, and the question here, if there are some references in the current literature that most important features of the product can be extracted with social network analysis, or everything here is being just invented by you guys. Because it's really risky. There are lots of ideas here, and they right now have almost no references. It's a bit terrifying.
Well, everything in here is mainly everything is in-house built. Yes.
Okay, so guys, generally that's okay for the course project, but this project really suffers from absence of any references to the research field. And we can discuss it deeper. Just pick one of the consulting hours and we'll spend time talking about it, because there are lots of references of different works doing the same things without social network analysis, and they're pretty good inside it. Yeah, and there are lots of problems where your proposed methods will not work at all. Starting from the from the ambitious words and ending the absence of context in your current model. Yeah, so there are lots of problems, and this requires more deeper discussion. Generally, this is some kind of very unusual, but yeah, I have said everything. Unusual, but a bit kind of not labeled to the existing field project. This is cool for your course project, but if you were doing something like a master's degree thesis, you would get a very poor mark just because
absent of references.
Yeah, and there are lots of things that guys have invented in these fields, and we should discuss it in depth. Otherwise, it will be useless. Okay.
Okay.
So
well, thank you.
And let's move on. The next speaker is Vera, Alexandra, and Vladislav about the subscriptions in different communities and social media. Yes.
Yep. Hello.
Hello.
Guess we're ready to start.
Each time I see a picture, it makes me.
Yep, we're trying to do it. It looks like Zoom is not very happy to let us show you the presentation.
It's better for us.
Can you try to fix it? Because without the presentation, we will not have a chance to understand anything. We can skip your talk while you're, if you're using Mac, you need to restart Zoom and to allow it to use, I don't remember something, yeah. But if someone has other operating systems, you can ask your teammates to share the screen.
Okay, guys, can you just share our screen? Because my Mac is not happy with that. Vera.
Sorry, I can't.
No,
Everyone has Mac, yeah.
I just not at home, that's why I use.
Can you send me the presentation at Telegram, and I'll just open it at my computer?
Yeah, Sasha,
Nice. Yep. Give me a sec, I'll do it.
By the way, guys, those of you who haven't sent me the presentations, it would be great to, if you'll do it right now, because yeah, there are lots of useful content there. I'd like to have them somewhere.
Okay, I did. Yep, it's in PDF format. I hope it's okay.
Yeah. So just 1 minute. Close. Sometimes screen started, and
Yep, so here we can see our topic, as you've already heard.
Yep,
that's the impact of subscriptions on affiliation in different communities and social media. And we want to devote our projects to this topic. So basically, we want to cluster users that are subscribed on university groups, such as HEC MEMS, for example, HEC Career, and HEC Case Club, and some other groups in HEC community, just to understand what kind of users we've got. So basically, we expect that we can divide all the users in applicants, students, alumni, and bots, and estimate the shares of each of these users. And Vlad, can you tell us, please, the next slide? Yep. And I guess Vladislav will help us to understand what do we need it for and what is our hypothesis.
Yeah, our aim is to make a cluster analysis that will give us the information that we could use in order to shape the content on these pages and on these groups, and also have a better understanding of what is relevant for the advertisement. Yeah, now next slide. And now
yeah. Actually, we decided not to take already the data set because we could not find data sets about HEC. That's why we decided to use web scraping. And according to our, we actually used your template as we can call so, based on parsing VK groups.
I guess you used something about Miladze.
Yes, Miladze. Miladze was like, we say about 1,000 type Miladze, but
Miladze is an icon, so we used it.
Yes. In our
I don't like Miladze. This was just one of the students' notebook that I have decided to share. So that's really funny.
But we really thanks to Miladze because it gave us a lot of ideas and hints. Without Miladze, we cannot survive.
That's
So thank you.
literally inspired us for our project.
Yeah.
Next slide.
What fields we no not next slide. We took such fields as birthday, city, country, last seen, sex, connections, contracts, domain, education, of course, because we have educational direction. Also, we took status and the attribute can write private message. With, for example, can write private message, we can understand the level of Sophia-phobia, the level of confidence of the people, because usually people who don't want to be confident, they don't allow to write message directly to them. And we just only on the way to start analyze our data. We didn't have quite great results like our group mates, but we will do our best in order to analyze it greater. For now, we started consider are there only HEC members in such groups, or maybe there are some other connections in the group, but we can see that on these two graphs there is connection between users and university. We can see that, of course, it may be obviously HEC group is the biggest one, but also the second one. It's like more smaller than HEC, but still there is strong, not strong, but some connection between MGU students. They also interested in HEC. For what reason we don't know, but we will later explore our data in order to understand all hints and know it in better way. So thank you.
Yep, we understand that there are a lot of surprises and interesting insights in the future for us. And I guess our last picture with the cat is not one of them, because you've spoiled it. You read it already. But basically that's it. Yep, thank you for your attention. That's all we've got by now.
So two main references. So just that's not really important, but I guess I should mention it. I guess Milad may have some sex, but HEC students have gender. Yeah, sounds a bit better.
Okay. Sorry, yeah.
Okay. And the second, in fact, this is a pretty good in terms of some practical implication, and there are lots of different programs for some business guys like TNS and Segmenta that tries to describe some group of people that are that may be interested in some product. Yeah, and there are lots of automation things done inside those programs, and it looks like you're doing something similar. Yeah, but generally, it would be really nice to formulate some quantitative, not quality goal that you're going to reach in your project before it ends. Otherwise, you'll have just a very, very long descriptive analysis that will not end with anything. Yeah, and so the good idea is so to maybe try some kind of marketing model. Yeah, just let's try to sell phones to all those guys. Yeah, and see if we have some strategy to do it better, or I don't know, maybe to see to try to predict if we can predict, I don't know, their marks from the social network, yeah, or any out of the network feature that can be predicted from this network, and this would make your research much more interesting. Yeah, you need some quantitative, not qualitative goal that can measure if your research is good or not. Otherwise, you'll just have a very long description. Try to think what can be captured. Yeah, talking about the HSC students, the idea about marks or grades can be pretty good, because I'm not sure if it's an open access, but most of the members of those groups are students that have already graduated from the university, and I guess you can find statistics of the graduation projects that they have done, which marks they have obtained. Yeah, I'm almost sure that this analytics can be either took from the educational office of the university or just from some public pages of the university. And if it is so, you can try to predict something from this network. Yeah, and this would be a much more interesting research rather than just the description of the HSC students. So this is the main idea. I'm not sure that if it is really close to your original point or not, but your project really requires some goal.
So, for example, we can try to predict the marks for the final project, which is
yeah, just as one of the options.
Yeah,
or at least the topic of the final project, because you have some text description, at least the title, and usually you can predict some topic from the title. So how can you predict the topic from the network structure? This is really interesting, because so there are some guys that are doing some math projects, others are working on sociology, economics, and these kind of topics should give you some ideas. Or you can find some information about the faculties of the university where they are studying and try to predict those features from this online network. So if you try to add some quantitative feature that you're predicting, your research will benefit from it. Otherwise, you will end only with the description, and this description may be really interesting, and you will find lots of insights, but this is the description for the description, and this may be not so strong. Yeah. Okay. So
yeah, thank you. It's really quite interesting, just because we have about 5 hours arguments about our final goal, but the ideas is really amazing. Not like us.
Yep, thank you. We're open to pivot, so we're ready to implement all the ideas. Thank you for your advice.
You're welcome, and once again, so I guess all students that have visited consulting hours have benefited from it. So you're welcome to go and discuss some ideas there. Okay, let's go on and talk about topic modeling of Twitter conversation. Sorry, guys, I haven't read your proposal. It's a shame for me, but so please, can you give some more details?
Okay. To start, we have some change in our topic because we have some troubles with Twitter data scraping. So we changed dataset, but the main idea is still the same. So today we want to present our project topic modeling on real news communities. To start, I want to present main points of our project. Next slide. So we want to analyze news articles. We have several goals. Firstly, we want to identify groups of people who often appear together in articles. And secondly, we want to make topic modeling for articles what associated with each group. Work can be separated on some classic NLP tasks like name entity recognition and topic modeling test, and also classic network analysis test like graph community detection. Next slide. Artem. Some information about dataset. To collect data, I parsed the new site using Beautiful Soup tool. We have two versions of dataset, small and large. Small version contains about 300 items from category politics, and large version collected 5 categories, and each categories contains about 500 items in each group. Next slide. To prepare data for graph building, I extracted person names from each article using Skippy model. Also make some simple normalization and some trick, make search of similar persons' names. We needed to prevent situation when we associated one person with several names. On the slide, you can see diagram where is distribution of mean number of person names in articles. So most number of names contains culture and politics categories. Next slide.
I guess my turn. The next step is in our pipeline is to build on the scraped data, the graph. The graph is represented via persons, and the edges between them is a number of joint mentions. So, for example, if we have Putin and Zelensky in one article, we have +1 in the edge weight. If no mention between persons, there is no edge. So but basically we wanted to scrap a lot of data, but we met some problem with graph building as we decided to use Network X, and it has a huge performance problems to build more than few millions of edges graph. And currently we decided to took only a sample of collected data and to analyze this sample. About collected statistics from graph, degree, meaning number of edges, not their weights. In average, it is 13, but median is 6. That can tell us about non-uniform distribution of degrees in graphs. And the same about weighted degrees. The sample of collected data is quite density, so we can see it's less than 5%, and diameter. In general, diameter is valid only for connected graph, but as our build graph is not connected, we decided to check diameter of largest connected component, and its value is 8. About more meaningful statistics, we computed PageRank coefficients and max values is a Putin, Peskov, and other political Russian political persons. Degree centrality and other centrality measurements showed us actually the same names, but I can say that in many of centrality measurements, Zelensky is on the top one in the sorted list, but PageRank, there are he on top 15 or top 20. So PageRank is also can be interpreted as a kind of domination in network. So our newspaper is okay, it's more about political. Let's get a look on our visualization. I can't visualize large graph to make it some meaningful information. So I decided to filter my graph to get some subgraph by top 30 by PageRank, and here how it looks. We can see some community structures already here. So it's on the bottom of the network. We can see some outside political persons, which kind of third-tier countries leaders. And another one on the top is Russian imported persons, but I don't know how Slutsky is appeared here. So it can be some data it should be excluded, I think. And another one is USA related persons, and we can see here also that the model SciPy models which Polina uses for person retrieval is not always so the model is to tune. Our idea is to tune the model. As you can see, we have Vladimir Putin and Vladimir Putin. So it's for not Russian native speakers, it's kind of Vladimir's Putin. And I think we can create some simple preprocessing by tokenization and other things to exclude and unite those persons into one Vladimir. So next slide about our future work. Polina, can you join me?
Okay, so as Artem already said, we plan to build graph on large data set. Now we have some statistic only on a small data set, and we plan to continue work on our project, make community detection, and also topic modeling. I believed that we use different topic modeling models to have some comparison. So that's all.
Thank you. Any questions?
Thank you.
Silence. Can you hear us?
Sorry, it looks like my Zoom is dying. I'll try to fix it, but yeah, it really works very dramatically slow. So, okay, you already see the first problem of your current project. problem. Yeah, there are lots of named entity duplicates that needs to be fixed. The second big problem here is your similarity function, because maybe you should take something like just Pearson's correlation, and it will lead just to better results. Yeah, so this can be also done here. Generally, so the question is, what is the goal of the project? Why do we need this tool? Yeah, because, okay, we want to model our topic with only named entities. Yeah, but why we are going to do it? What is the final goal?
Just interesting to create some group of people that we can see in the same articles, and we can associate some group of people with some topics. Maybe we can predict something like profession, I don't know.
Generally, it can be used in some recommendation models, but it will be only a small part of the recommendation model.
So you need to find some goal for this study. The other thing that I thought, and in fact I have built lots of those kind of plots. Usually you use them just to describe some kind of, so this is some kind of mind map that the analyst may want to use when he is analyzing some field. So what are the most important persons inside this field? Yeah, but generally it's a bit discussive. Maybe you should also add other named entities, not only people, but organizations, countries, and so on, just to make this map more kind of more, add more data here. Yeah, and this would be a bit more interesting. The second idea that can be done here is just to analyze how those entities evolve through time, and if there are some patterns for this evolution. So I mean, so there's some entity like Zhirinovsky appears and then disappears, and try to predict any insights from these dynamics. Something similar to the topic told earlier. So for example, you have some financial correlation, yeah, and if there are some correlations between, for example, Zhirinovsky and Peskov, if Zhirinovsky arrives only in contexts of Peskov for a very, very, very long time period, then maybe it means something, yeah, because so he's not interesting just alone, yeah, he's interested only in some kind of co-mention with some other guy, or vice versa, yeah, and you can try to find these correlation trends on a long distance if you analyze enough of news, at least something like a year or maybe 2 years period. Maybe this would give you some new ideas. Generally, so there is lots of problems with natural language processing here that we already see, starting with Pisok and ending with Jo. Yeah, so, and of course mapping those entities to proper groups changes the final plot, because so there are lots of nodes that will get higher weights if you map them to a single node. So many things should be fixed, but the main question is what is the goal and what can be done next? This you need to think about it. One of the possible strategies, as I said, is to try to analyze the time evolution of those maps. If, for example, build them each month and see if there are some patterns here. So I'm still not sure that this is the good strategy. Maybe we need both to think about it. Yeah, all the rest looks pretty interesting, and in fact, there are many application cases where this map can be used, but they are more kind of the qualitative description of some field. Yeah, usually they're used somewhere there. So these are main ideas. Okay.
Okay, thank you for your comments.
Can we move on? Graph models for household speaker recognition. Igor, Evgeny, you're welcome.
Yes. Yes.
And if you try to be a bit more quick, that would be really great, because we are really moving slow. Okay.
Right. So without further interruption, let's start.
Excuse me, but I thought that the next in the table is the presentation, like from Karatsetska and Vlasova. I think that you missed us.
Yeah. Sorry. Yeah, guys, let's talk about the political image because
okay,
the correct order. Sorry.
Can you see the screen right now?
Yeah.
Okay. Unfortunately, we have changed our theme 2 weeks ago, as our team has changed, and we decided that the knowledge gotten during this course should be implemented for our future career. And as both of us, me and Victoria, are from the Faculty of Social Science, and our specialization is political technologies, we decided to think over how we may implement this knowledge in our future career. And so that's why the theme of our project is the accessing the politician's image through building the menthions network. So, sorry. As for our data, it's textual data of comments. We decided to try this method on the example of the region's governor, and we chose the case of Lipetsk region. So our data is comments left by people on the personal pages of the politician and the social network of Contacte and Instagram. We choose these networks as these particular politician has personal accounts only in these two networks. And as for the roles, you may see it in the screen, but both of the projects we do together as we are group mates. And about the project and the goal of the project will continue my colleague.
Yeah, thank you. And what about our project? So as politicologists, we are interested in politicians' image as in a key point of understanding how effectively an electoral campaign is organized and what chances of winning are. We convinced that social networks allow us to identify whether the electorate is loyal or not. So we are gonna analyze comments in social networks because we sure that comments could reflect true reactions of users and of electorate in basic. So the goal of the project is the purpose of the study is to test the functionality of network analysis to accept the public image of a politician. And we decided to take a case of Igor Artamonov. So the next slide. And what about our empirical strategy? So the first step is collecting data. The methodological architecture is based on textual data, post comments and reposts in the social networks of Contacte and Instagram. Secondly, is building a network and graph. Approximately we analyzed 5,000 constructive comments that were collected to identify how residents of the Lipetsk region evaluate the governance management decisions. The most common words will be visualized as a network of mentions. So the final step is interpretation, the network, and making conclusion about image of Igor Artamonov.
I will continue. Unfortunately, there is a small mistake in the slide. We decided to analyze only comments, and we decided that posts are mostly written not by people, but comments may show particularly people attitude, and that is why. As for the data description, yes, we collected 5,000 comments, and it's textual data, and more than that, we have data about the authors. We have data of age of the part of the authors, about hobbies, marital status, and education. And we think that this data about the authors will be useful for us in the next step of the research. As for the network, it's our network, and it's the most common words that are used with the name of the politician. And the thicker the line connecting the words, the more often they are mentioned together in the comment. Words that are not connected by lines are used together to a minimum extent, or are not used together. In this step, we may also see some groups. We may see like the blue part, and this part of the comments mention the past of the politician, his ex-work, his ex-career. Then another group in the right shows a negative attitude of people to politicians' membership in United Russia, and also in this group we may see the idea that he has like small chances to be re-elected. And on the bottom of the network, we may see comments mentioning politicians, politicians' activities, and some political aspects like regulation of prices and salaries in the region, including high salaries of officials and the governors itself, like comments about healthcare, education, and transport. For the next step, as we have information about the authors, we think, but we haven't checked it yet, that each like group of comments is left by a particular group, like for example, particular social group, like for example, women near 30 or something like that. And we think that our method in the work of political technologies may be like a kind of innovation, as this method, the advantage of this method is that it gives an idea about those aspects of governance image that cannot be identified using like manual analysis of the comments. And more than that, our results is there is a theory, and our results is similar that tells us the theory about the components of the political image. So that's all that I wanted to say. And that's the end. Thanks you for your attention.
Usually when you draw this kind of mind maps, so first of all, what the color means. Is there some legend behind the color, or is it just the community detection stuff?
Yes, it's community detection.
Okay. I guess so. Three things can be done here. First of all, when we visualize this kind of mind maps, they are kind of very dirty, and different language elements like verbs and nouns play different role. And you can see that there is the verb управлять, назначать, and at the same time you have some entities like Sberbank, bank, and so on. Yeah, and so they play different functional roles in the language, and their centralities and all their features are a bit different. Yeah, so that's why those maps are always noisy, and maybe. Okay, first of all, it would be really nice to group Artamon and Artamonov, yeah, which most likely makes sense. So make some kind of NLP case data curation. Yeah. Secondary, we could say that verbs and nouns play different functional role. I mean, it's some kind of bipartite network where you have all verbs connected to all nouns and not connected between each other, because very rare you'll see that somebody is управляет, зарабатывает. Usually he's either управляет, either зарабатывает, most likely. Yeah, and so visualizing this kind of map, you mix a bipartite network to and try to interpret it as a single partition, and don't take into account the structure of the language. Yeah, so maybe verbs and забыл, называется депричастие. Причастие should be taken as some separate partition of your network, and it will lead to some kind of more interesting results. So you can project the connectivity between Sberbank and Artamonov using this number of connections with verb управлять. Yeah, and it will be more kind of makes sense to me. I understand that it highlights that he took part in the governing of some bank. Yeah, and there is some semantic behind it, but it looks like it would be better to put this semantic at the edge type, and it will your visualization will benefit from it. Yeah, this is just the first idea. The second idea is if you can check if where your topic connectivity maps to the network connectivity, because maybe some people are talking about his past at the bank structure, and other groups are talking about some words like чиновник, зарплата, and so on. And if those groups are connected and they're talking about the same things, this is some kind of interesting correlation. But maybe some groups are talking about everything and some groups are focused. So if you try to compare the topic structure with the network structure of the users that are talking about this, you will see some other highlights. Yeah.
Okay. Thank you for your comments.
But I guess this bipartite structure can really be fixed because have you got the idea why it's a problem?
Right now, I frankly speaking, right now I haven't the idea, but after the seminar, me and my colleague will think over it.
I'll try to say it very quickly in Russian. У вас как бы получается двудольный граф из разных слов. То есть существительные, они между собой соединяются глаголом. Петя купил дом. И когда вы рисуете плоскую карту, в которой сущности разных типов смешаны, это примерно как рисовать одновременно там, ну я не знаю, университеты, на которых люди учатся, и людей. То есть, какие-то в общих университетах учились, какие-то не в общих. Но у вас управлять может кто угодно, чем угодно. Поэтому рассматривать это как полноценную связь не совсем корректно. И здесь более правильно сделать проекцию по глаголам между существительными. От этого ваша визуализация ничуть не ухудшится, потому что если этот глагол важный, вы можете его повесить на ребро между этими существительными. Но структура связи при этом совершенно поменяется и станет более прозрачный. А так у вас какие-то подвешенные узлы, зарабатывая, не знаю, там, что-то еще. Ну, в общем, я бы сказал, что здесь вот глаголы надо анализировать как отдельный вид сущности, потому что язык русский так устроен, да и любой другой язык. И тогда у вас самовизуализация сильно поменяется. Вот.
Мы можем, например, убрать глаголы вообще тогда из этой цепочки?
Нет, убрать их вообще неправильно, потому что в них ценная информация. Мы же хотим знать, что он управлял Сбербанком, но я бы, как бы перевзвесил связь между Артамоновым и Сбербанком, как-то там добавив в нее информацию, что они там соединяются через глагол «управлять». И можно это сделать через условную вероятность. То есть, грубо говоря, если у вас 90% связи между Артамоновым и Сбербанком также проходит и через «управлять», то как бы, корреляция между вот этими словами очень высокая. Значит, просто между Артамоновым и Сбербанком на связь можно повесить лейбл «управлять». И это будет гораздо более понятный и совсем другой граф, чем тот, который рисуете вы, потому что у вас некоторые узлы как бы являются узлами двудольного графа, а некоторые узлы являются узлами плоского графа. И вот это вот смешение, оно, как бы, на самом деле, не имеет под собой какой-то семантики или сути, за исключением того, что так язык устроен. Вот и все, до чего я там докопался.
Хорошо.
Просто попробуйте вот обыграть вот эту вот глагольную функцию. Ну и, конечно, там как бы этот Артамон, не знаю, там Песков, Песок, с этим бы, хотя бы там в рамках того модельного массива, с которым вы работаете, хорошо бы что-то сделать, чтобы самим стыдно не было. Потому что, опять же, при объединении узлов у вас картинка совсем другая получится.
Спасибо. Okay, and the last question. Should we send you our presentation or it's just okay to show it?
Let's say please send it, and this will be a
Okay.
condition for everyone. I'm not going to use it anywhere. I just want some kind of references that can be extracted without watching the video from the very beginning. I'm absolutely not going to show it to anyone else or to use it somewhere outside our course if you're afraid about it.
Okay. Thank you very much.
Okay, so let's move on with the next block about the speaker recognition systems.
Yes. So once again, let's start. Graph models for household speaker recognition. We'll start with speaker recognition itself, and it's a problem of recognizing who is talking in the audio, in identifying the label of speaker. In particular, we are interested in household scenario, where we have a family, which is a set of known speakers, and we have guests, which are unknown speakers, which we only have to label as guests. This means that our system has to maintain some personalized settings for the family members and maybe use some defaults for guests. So in our project, we are given at first the pre-trained speaker embedder, the neural network which constructs the embedding, that is fixed vector representation of waveform audio. And this embedder has no prior family knowledge. And these embeddings are trained in such fashion that the cosine similarity of them indicates the similarity of speakers for given utterances. And while we are working with the family, we are given several utterances which we call enrollment. That is the utterance for which we know label, like the person in family who uses the smart device, it first enrolls in the system with the recording of his or her voice. And we will use graph methods for the task of household speaker recognition. That is, we treat every utterance as a node in our graph, and we compute the embedding for every node. Then we construct the fully connected graph, and we use the L2 distance, or in fact, the cosine similarity between embeddings as a similarity measure to define the edges. And we obtain the following adjacency matrix. And we set the diagonal elements to 0. And the algorithm goes like this. We then construct some matrices, and we iterate some process while minimizing some functional. And then we obtain the new labels for unknown data. So while we are not given some data for actual families, we will utilize the VoxyDep dataset, which is a corpora of short clips of human speech extracted from YouTube. It contains many speakers and many hours of speech. And our algorithm will work in separate sessions. And during a session, we sample some labeled speakers as family and some other utterances not from the speaker and as guests. So the applications of this algorithm are as follows. They can use it as is for predicting the label of new utterance. It may be working okay in the initial iterations, but it will become too slow with time, and basically 1,000 utterances becomes really intractable. Or we can use this graph for label propagation on some collected data during the usage of our smart device. And we can use label propagation and train some classificator for family in self-supervised paradigm. That's it. Ready to answer your questions.
Denis, the question at the chat, I guess I'm going to listen to all the presentations, but if someone that is going to talk at the very end is in a real hurry, you can ask for other students to let you speak earlier. Yeah, and we can try to fix it somehow. But really, yeah, it looks like it will take more time than we're supposed to with our schedule. Sorry for off topic. Igor, Evgeny. So the question about your project is the following. We have some distance between different speakers that was measured from the quality of the from some vectors of those guys, yeah, and we're going to use.
It's not for the speakers; it's for utterances.
Sure that it's the same. Just a second. Still, what's the difference between utterance and the speaker? Can you? I don't know. Can you tell it in Russian? Because it looks like I cannot get the idea from your current speech.
Utterance — это запись.
Ну, но она привязана все равно к какому-то спикеру, которого мы хотим идентифицировать.
Да.
Так. Ну.
Вот, сходство мы считаем между utteranцами. И сходство означает сходство спикеров. То есть вектор, который мы строим эмбеддинг, это эмбеддинг не спикера, это эмбеддинг utterance.
Okay, that makes sense. And why we do not want to use the information that all the utterances belong to the same speaker?
Because they don't belong to the same speaker. We have like some classes which are the members of family and guests.
But we know the true labels, so that several utterances belong to the same speaker.
Yes, yeah? We know the enrolls, but then we are given some new records and we have to predict for them.
Okay, so generally speaking, the thing that looks that your work refers mostly is the area of knowledge injection, and there are lots of applications of subnetwork models in terms of the injection of network information inside the current model working process, and your recognition or kind of classification task could really benefit from adding additional knowledge about the utterance position in the network, because you can not only limit the number of possible hypotheses, but also use the specialized model, the specialized speaker recognition model exactly for this utterance, or at least use some kind of weighting function for the generalized model. The question that I'm still a bit confused. So, and this idea is kind of very interesting and promising, especially if you go inside the current speaker recognition model and see how to inject this information better. So the main question that I was already asking is that, so first of all, you need to find the good injection mechanism. Secondary, you need to build the network that really stores the information that helps to solve this problem. And thirdly, usually the injection is done from some some additional resources. Yeah, for example, you know some kind of graph structure of all speakers, and you can use this graph structure to understand that so they are similar, and you use the compactness hypothesis. In this case, this still can work and help you to improve the quality, but it looks like you need to build the embedding first, and this means that you need to do the entire recognition and then to use this embedding that was already done by the speaker recognition model. Sorry, not speaker recognition, but some speaker analysis model, and then pass it to the speaker recognition. It means that you need to use your model twice, and one model will be based on the previous model result, and this is a bit dangerous. Yeah, I'm not sure that that my explanation was clear enough, but I have spent a lot of time on working on different injection models, and I guess the best thing that we can do is to discuss it just outside our current seminar separately, because I can give you some highlights, what you can try and what can work and what cannot. And secondary, we can discuss how to inject, how to build the network in a better way. So some kind of shortized comment for your work. So it requires more discussion, but the idea is very promising. Okay.
All right.
Okay, sorry for that. And let's try to move on. Must watch movies all time.
Yeah, good afternoon. We're here. One moment. Can you see my screen?
Yeah.
One moment. Sorry.
Не надо слайд-шоу. Ну, ладно.
Okay.
Yeah, good evening, everyone. Can you hear me?
Yeah. You can.
Yeah. Great. And today we are going to talk about the progress made in our project, and especially we'd like to share with you our findings and results. But before diving into them, I'd like to make a brief overview. Therefore, next slide, please. We decided to go into the realm of cultural studies and modern culture, namely cinema. Therefore, we want to explore certain relations between films from different eras. And we believe that the results of our work actually will be quite useful for students who are engaged in cinema studies. As for the idea of our project, it is to analyze top 1,000 movies from Russian online cinema Kinopoisk. And as for the main goal is to find out during which decade the most cult films were made, and which country has made the greatest number of them, and how often people watch them. These criteria, we think, help us to understand the true cult level of every film for the society. And one more point to mention here is that using some feature from the most cult movies will make it possible to create another one. I'd like to pass the word to my colleague Sofia. Please tell us about our objectives.
So on this slide, you can see the observations, objectives of our project. Firstly, we have uploaded 6 variables: title, the title of the film; rating, the rating of the film; year, the year of the film's release; country, the countries of the film's production; genre, the genre of the film; and number of rates, the number of rating received by the film. Secondly, we conduct an observation on the example of the 1,000 films according to the top Kinopoisk version, and we are planning to use cluster analysis to explore connections between data. And thirdly, it's necessary to draw conclusions from the data and to visualize the results with graphs. The next slide, please. To achieve the goal, we decided to create a Python code that would help us to gather all necessary data from the service. For working with data, we use specific Python libraries. You can see the examples on the screen. So Kinopoisk has a powerful protection system. So we used more libraries and model like time, random, and user agent. And the next step is to analyze and visualize collected data.
So on this slide, you can see our data frame. As you can see, there are, as we already mentioned, 1,000 films. And the first one is, so I don't remember the name in English, Shawshank Redemption, I think. Yeah, something like this. And also you can see that at the end of the list, there are some films with a rating 0 and with 0 number of rates. So it means that they are not really popular between Kinopoisk users, and that's why we will use this fact for future analysis. Here you can see the data structure, the characteristic of the data. As you can see, the most popular ratings of films are close to 7.5. And as you can see there are only few movies which have a rating around 10. And also we can compare it with this table that the rating of the first movie is 9.1. Also you can see that the country which produced the most films from this list is the United States of America. The next one is United Kingdom. Later, the next one, the third one is France, and so on. So this is all. We'll get to hear your questions, and we will plan to continue our analysis and to make it more visible for our purpose. So thank you a lot for your time.
Let's start with the question. Where is the social network analysis here?
But why not? Because Kinopoisk is also a social network where lots of people.
What methods of social network analysis are you going to use?
Now we are at the beginning of our research, and we will do it a bit later.
Okay, let me give you several ideas. Generally, your current project goal is some kind of sophisticated rating prediction. Yeah, because generally you used the word cult or kind of, so this means that this is some kind of movie that has a good rating for a very, very long period of time. Yeah, for example, The Godfather or this Shawshank Redemption, yeah, they're popular for years. But generally, there is no difference between predicting the popularity for long year or the popularity for a short period. I mean that, so you can either combine two these variables or analyze them separately. Generally, this is the problem of rating prediction. Yeah.
Yeah. Yeah, okay. We got it.
But your rating prediction differs from the rating prediction of Kinopoisk because you have some kind of regression between year and rating. And if some movie is pretty good and pretty old, then so it will get higher weight of your biased rating. Yeah, that's okay with this model, but generally this is the class of the rating prediction model. And there are lots of existing research around rating prediction because so Rotten Tomatoes data set and this competition, you can win $1 million if you predict the rating of the movie that is going to arrive. Yeah, and many guys have spent lots of time building these models. It's a very old and well-known problem. And of course, if you're doing this rating prediction problem, you should refer to all the guys that used to work on this problem before you. The second idea is the student should read the relevant literature about his problem, especially the literature written by his scientific advisor. So you can find one of my papers about the rating prediction of movies based on social network analysis. And our idea was that we can take into account the information about the filming crew because it really defines the rating of the film very strongly, and you can use all this information. So I highly recommend you some kind of using this idea and adopting into some kind of more contemporary models like graph attention network. So you can build movie connectivity based on the film crew. And in this case, you will see that, I don't know, some movies are more or less close to each other. And then you can use this network information simultaneously with the structural information like genre, country, and amount of money spent on this film to predict the final rating. And it will lead to some better results. Okay.
Yeah, okay, thank you a lot.
Generally, you can just open this publication and it's published in Archive and read it through. The problem, one of the problems that you will occur here is that, so first of all, if you'll try to do this for EMDB, the year, the country of the film is very noisy there. Yeah, because so they write the country where this title was used, but not the country where this film was made. And it's a very big difference here. Yeah. So the second problem is that it's really difficult to extract the information about the film crew in terms of scraping because you get banned by Kinopoisk while trying to do something like 6 requests, and you need to make something like 1,000 requests because you need to get data about the crew for each film. Yeah, and it's much more requests. The good news for you, I have done it already, and I can just share this data set with you, especially if you will follow these recommendations of the further work inside your project.
Yeah, thank you. It will be great.
Okay, just book some consulting and we will discuss it in details.
Yeah, thank you a lot. Yeah, okay.
Okay, great. So let's move on with the mood of the nation.
Yeah, give me a second before I share my screen.
Yeah. Can you hear me? Please tell.
Yeah. Everything is okay.
Okay, hello to everyone. We're going to present mood of the nation during ongoing crisis. So, yeah, we will skip this part. It's just our requirements. And on this slide, you can see general information about our group and how we structure the work. So the idea and background of the project is that we decided to focus on current crisis, and so the object of our research is social media mentions in Russia or in Russian language that helps us to understand mood of the nation. We try to focus on the idea that now many research like pay attention to the percentage of those who approve or disapprove for special military operation, but the time is really, the topic is really topical, so-called, but no one pay attention to the mood of the nation and what is going on in the head of just a simple, regular Russian citizen. So we decided to deep dive into this topic to understand what is going on. Please, next slide. That is why our aim is to understand key topics of discussion and to analyze this topic by sentiment and semantic content. And next slide, please. So we scrap data via UScan, preparing special search query, but due to some limitations for now, dataset is just about negative adverbs related to the mood of the nation. Probably later we will be able to change that, but not for sure, because we have some problems with UScan license. So as a result, we used as well filters by country and language that helps us to work with VPN data, because we try to use like a combination of country or language plus undefined. So thus we can collect data from Instagram and Facebook as well. So please, next slide. After the first step of data processing and cleaning, we got a bit less than a million of mentions that we are going to analyze. And here you can see variables that are that there are in this data set, like from the general one, like daytime, I don't know, snippet, to those that were called manually, like a text one, like discrimination, problems in finance work, and so on and so forth. And then Anton will say about data in a detail.
Yeah, so here, so for the beginning, we decided to take a closer look at what our data tells us and what it can give us, because the manually tagged posts are very sparse, and we can't really judge by them what is going on in the hearts of the people who leave their comments or posts on social media. But the here is the one particular data type, which is called subjects, which will allow us to know what kind of topics are the hottest one. But before that, we somehow
why some circles are green?
Well, Sveta, why some circles are green?
It is just a semantic trend. It's like automatic defined by UScan. So each point is a trend, mainly related to some news, and red one is a negative one, and the green one is a positive one, blue one is a neutral one.
Yeah, that makes sense, but you used the list of toxic verbs, but some circles are green.
Yeah, sure.
Yeah, the data is a bit more difficult because not on some text snippets which are in the database, even though they were collected by choosing some negative or toxic content, still they have some like neutral or positive semantics. So one of the next steps which we will do is perform some kind of advanced semantic analysis with language models to extract some knowledge which is a bit more exquisite than the text provided by USCAN. But before that, we cleaned the data because there are some duplicate posts which we excluded from the database, as we claim that they are from, I don't know, bots or something. Then it is also important to take a look at the number of unique users, because the final graph that we will be building will be constructed from like people. They will be edges, I'm sorry, they will be vertices in the graph, and we are deciding like how will we connect people between each other. So when we took a look at the subjects which were found in the posts or comments of the people, it was unexpected, well, honestly, expectedly, that like health, war, economics, or politics were the hottest topics. Like the next most hottest topic, which is not on this picture, was related to children, with some like 40,000 occurrences in the data, and everything else like auto, sport, and something. They yielded not many information to this. So for now, our next goal is to connect users by the themes they mentioned, because on the previous slide you could have seen what kind of topics are covered by the posts of the people. So by connecting the people when they mention some themes, we can somehow see the clusters of interests, like what are the most important things people talk about on the social media, and how do these themes flow from one cluster to another, because every person can post information which covers different themes. So that is what we are going to do and what we will look at. Additionally, as I said earlier, it might be a good idea to use large language models to extract additional information from the texts, which maybe we won't be able to describe what exactly does each embedding mean, but it might help us to build additional connections between people, or build the connections by themes in a more intelligent fashion. So generally, we're still thinking on how to construct an appropriate graph to make some final claims about the mood of the people. Yeah.
Okay, let's be quick. 3 questions. Question 1. Who do you know the population of the countries that are most presented at the Kontakte network?
Like probably the ex-Soviet Union countries,
yeah,
mostly Russia.
Yeah.
So, but
so I guess this is something like 3 and maybe 350 100 millions. Yeah,
probably something like that.
How many accounts are now registered at Kontakte?
No idea.
600,000, 600 millions.
So you
It's like the idea that we cannot say that a mention or an author is equal to a person. Yeah, we know that. We will take that.
And we cannot say that there is just some fracture of fake accounts there. Half of the network, at least half of the network, are fake accounts.
Yeah, that's a problem, but just by looking at the data from the social media, it will be quite difficult to, just looking at the data that we have, it will be difficult to understand which accounts are fake or not, but it will still, I don't know, at some extent we can judge on the data, on the results that we get, compare them with some appropriate social analysis to say something about how can fake accounts form opinions, for example.
I'm just highlighting the problem of this research, and this is a really severe problem. I have the same problem. I spent at least 3 years removing these fake accounts from data sets, so it's really hard. Okay, second problem. You are saying that you highlight the mood of the nation, but your data set was formed by the query to the Duiscussion database to extract posts that contain special verbs. And can we be sure that these verbs really describe the mood of the nation? We do not have words like, I don't know, love and bought, but we have the very interesting word borrow and something like this, yeah? And especially borrow terrifies me a lot, because там было слово «займ». Я, как человек, который поел говна с социальными сетями, очень хорошо знаю, что будет, если написать запрос с этим словом. Вы всю рекламу, все...
Какое еще раз слово? Подскажите, а то не слышу.
Займ.
Займ? В смысле занимать?
Ну да.
Вы понимаете, что будет, если поискать в соцсетях слово «займ»?
Ну, микрокредиты,
конечно,
да,
мы использовали не просто слово «займ» само по себе, мы использовали негативные прилагательные в контексте со словами «настроение», «состояние», бла-бла-бла, в контексте со словами «займ», там, «деньги», «зарплата» через какой-то оператор, который говорит, на каком расстоянии могут быть эти слова. Ну, то есть мы как бы располагали эти слова не просто хаотично, там, «займ», «деньги», и смотрели, что будет в упоминании.
You took lots of negative verbs and lots of verbs with negative context. My general methodological question is all the same. You're analyzing the data set that you want to analyze. You're not analyzing some kind of thing that people are talking. You're analyzing some data set formed of the keywords that you were interested in. And this is very biased from the original structure of the data set.
Yeah, maybe we should...
There is nothing that can be done in terms of your current course paper. I mean, it's okay for your course paper, and I don't ask you to fix it right now. I'm just highlighting the methodological problems of this research if you're going to use it further. Yeah, all the rest is pretty good, but these two blocks are real problems. The third problem here is that, I'm not a big fan of Duiscussion. They really do pretty good crawling strategies, but all the rest of their system is very shitty. Say hello to Alexander. I have talked to him a lot, and he agrees that their system is very shitty. Yeah, Alexander is the CTO of Duiscussion. Generally, I don't like their topic detection that you're going to use. I don't like their sentiment detection. It's really very noisy. There are lots of mistakes there. So my general idea is that if you have any options to extract topics by yourself, doing some clustering analysis or wherever it is, if you have proper computation capabilities that can be used for this project, it's better to extract topics by yourself rather than to use predefined USCAN topics. First of all, because there are too few of them. Secondary, because you don't know how they were built and generated. You do not understand the algorithm behind them. Thirdly, because I don't like them. Yeah. So I'm not sure that this also can be fixed in this work, just because it's the course paper and you cannot do everything. But this is another methodological problem of your current research. Okay.
Yeah. Okay. Thank you.
Generally,
We'll
your
think
idea
about it.
is good and your data set is good and everything is good, but three of these points really block you from doing a good publication if you will somehow want to do it.
Okay, thank you for the details. Yeah.
Okay, so let's move on then. Student behavior patterns.
Yes, hello. The topic of our research is analysis of student behavior patterns when using large-scale public online learning. Next slide. So our team, so here you can find our project repository and also the Google Drive. And our team consists of 3 people, and here you can see them. The core description of the project relates, the next slide, please. Yeah, so it relates mainly to the popularization of online learning due to, especially to COVID-19. But we are questioning how that influenced the behavior of students, such widespread implementation of online learning. So in the process of learning, students may acquire different patterns of studying, for instance, and these patterns can be also defined by their social cultural characteristics. And so these patterns may also include their changing of roles. So when they are changing from being student to being teacher, because online learning mode is quite flexible in that. So there are some quite many research that introduce social network analysis to patterns of online learning, but like they have mainly some few problems that firstly, they either focus on only roles with employing some additional variables from for instance, linguistic field or some other not related field. And also they use SNA as complementary method. So they are combining a few other methods to achieve their full understanding. But we instead will use the social network analysis as a core method, and we will define the general behavioral structures of student network, and we will also address adapted roles of students. So please, the next slide, where I will, so the research goals, we have kind of 3 research goals. Firstly, we will identify patterns of student behavior. For that, we will use the large-scale public online learning Juni Academy, where we will see this number of students and how they are, what are their patterns within the online learning. We will create some topologies of students based on the social cultural characteristics and behavior pattern. And thirdly, we will analyze in accordance with the identified types of students, their models of interaction within the framework of the teacher's student model, where the roles of the student can be changed. For that, we already passed some steps. We already conducted the literature review. data collection, and we are on the step with the mainly with the preparation with descriptive statistics, and we also have to conduct the exploratory analysis itself and go with interpretation and data visualization. And now my colleague will continue on the description of the data.
Okay, we have taken the database from the Junior Academy. It is website with the mathematics tasks in Taiwan, where students can make their tasks, and there they have some activities connected with their teaching to each other and creating their classrooms where they can to help each other with these tasks. And in this database, there is 72,000 of students and more than 1,000 tasks in their Junior Academy. And in this database, we can observe how the students to do these tasks and which problem they have. For example, they can't do this task, and we can see how many seconds, minutes they need to deal with it, and other indicators to deal with these problems. And here we also two additional tables where we can see the characteristics of students, such as gender, their town, and their time, also their their roles in this Junior Academy, such as their creative or their creators of classrooms or teacher. And here we have more than 16 million observations for the students, and we have done the random sampling of only 3,000 students, and there are 1 million patterns. And we have done the analysis only the beginning of the distribution of the most important for us indicators. It's the indicators such as role of the student as a teacher or only as a student, or their role in the creating of the classroom, the creator of classroom, or only the participant of the classroom. And after this, we are planning to form the nodes as students with their characteristics and their behavioral patterns, how they deal with the problems, and connect them with each other by their roles as teachers and as students. That's all.
Okay, guys. Очень интересно, ничего не понятно. So how are we going to build the network once again?
The students to connect with each other by their role. They can be only a teacher, or they can be only a student, but they also can be a teacher in this Junior Academy, in this website, and they can help to each other to studying. And we
different students are either only students or more kind of involved and participating in this educational process.
Yeah.
And we're going to find some kind of assertivity patterns where some students are very high degree, collaborative, and see if it affects their grades.
Yes.
Okay. I'm pretty sure I have heard at least 3 papers at the Sunbelt conference, but all Sunbelt conferences, about analysis of some kind of traditional schools, not online platforms, but some kind of surveys where some guys went to school, took the information about student grades, and took the information about how those students collaborated with the other students in the class. Yeah, and there is a lot of kind of traditional analysis in this field, and maybe you can borrow some of the methods from this traditional analysis because it's very, very popular. There are lots of models proposed for this. Yeah, all the rest looks fine, and the data is also pretty good for the social network analysis.
Thank you. Okay, thank you.
I don't remember the name of the guy, but so it's very well-known data sets of children that went to the high school and their collaboration matrices, yeah, and it's some kind of standard data set, and lots of research was done on it. I'm not sure if there was the grades information, but there were some external statistics there that can be used for some prediction models. And of course, if we're talking about the classification task, and generally this is some kind of classification where you can either add the regression layer or some kind of split your grades to several bins wherever you like. You can always solve this as a classification task. So this is something that can be done really well with some kind of more kind of simple or advanced embedding models. So you need to transform your current network to the vector embeddings and then try to make some predictions based on these vectors. You can either train your embeddings simultaneously with the classifier using some GAT model, or make separate embedding with node-to-vec or deep walk, and then jump to the classification task with wherever tool you like boosting or what you prefer more. But yeah, everything is clear and everything should be done here. Okay, so Romans of the Three Kingdoms. Guys, generally we are already out of time in terms of our ordinary classes. So I guess those of you who are not interested in further talk may leave, and of course you can do it even earlier, but I still want to listen to the other guys, so we can either I'd rather prefer to continue right now because we will not have any other time slots for this activity. But if for some of you it's the problem, I can propose you some extra time, for example, tomorrow or anywhere outside the classes. Yeah. So
actually, that would be pretty cool for us. I mean, I didn't ask my team, but I'm guessing they will be okay with it. But yeah, if you can if I can we can present tomorrow, that would be pretty cool actually. But if you're not okay with it, we are ready. But tomorrow would be pretty, I mean, much more beneficial and convenient for us.
So tomorrow I have the seminar that ends at 11 o'clock Moscow time. And those of you who are dying already and do not have time now can talk about their project tomorrow at 11 o'clock.
Great. Thank you so much. Thank you so much.
Okay, so but are there other guys that want to leave now? Let me check our table. So I got the diffusion rate will be tomorrow. I'll highlight it as orange. And all the rest are ready to continue talking, yeah? Okay, so then the Romans of Three Kingdoms.
Okay, a second.
Aha, Christina is also a renegade. Okay.
So can you see my screen?
Okay, good evening, colleagues. Our project is social network analysis of the Romance of the Three Kingdoms. And today we are going to explain why we chose this novel and where we are now. For those of us who are not very familiar with traditional Chinese culture, I would like to introduce this novel first. Next slide, please. Romance of the Three Kingdoms is one of the 4 ancient Chinese classics. The other 3 books are Water Margin, A Dream of the Red Mansions, and Journey to the West. Romance of the Three Kingdoms is a historical novel based on the history of China's Three Kingdoms period. It refers to the Three Kingdoms. Here I mean the pure history book written by Chen Shou, and to a certain extent not only vividly shows the political and military conflicts of the Three Kingdoms period. Moreover, this book is also a reflection of the public opinion on this period of history in late Yuan and early Ming periods where Luo Guanzhong, the author of this book, lived. Next slide, please. I mentioned just now that this is a history-based novel, which is why we chose this novel for our research. So as a novel, The Romance of the Three Kingdoms not only describes history, but also contains the author's personal understanding of that period of history and personal feelings of historical figures. Next slide. Therefore, as a novel with complex relationships between characters with official history as a contrast, and some histories have obvious and some stories in this novel have obvious traces of artistic processing. It makes us interested in the social network in it. As a well-known novel, its high-quality English translation provides us with more convenience. Here I just want to clarify that we do originally want to use the original text, the novel, as a data set. But because Luo Guanzhong used half classical and half modern languages, modern Chinese, that was difficult to deal with. So we ended up using the English text as the data set. Of course, as we are using the English text due to the translation could not fully express the original meaning of the text, the result may be biased. Next slide, please. So the key idea of our project is to simplify the analysis of complex relationships in a novel with the help of algorithms and make literary research more objective and convincing with quantitative methods. Next, I will give the floor to Zhou Zhengman to introduce you about our current state and expected results.
Okay, now we are going to talk about the goals and the steps of our project. Our project aims to generate the social network of the characters in this novel using natural language processing technology. To review the text style of the novel using social network analysis, and to compare historical novel and historical facts using quantitative methods. And our project can be divided into 5 steps: getting text data, pre-processing text, extracting networks, analyzing the structure of the social networks, and analyzing the main characters with page rank, centralities, and so on. And talking about our research data, yeah, the raw data is the English translation of Romance of the Three Kingdoms by Brevet Taylor, and we have already scraped the whole text from the internet. And when preparing our data set, we also conduct tokenization, named entity recognition, and extract the networks from the text. And talking about network design, the nodes of our network is the characters of the novel, and the edges are determined by the co-occurrence of 2 characters in the same paragraph. And if 2 characters appear in the same paragraph, then we consider that these 2 characters have some relationships. And if these 2 characters appear in the same time more frequently, then we consider that they have stronger connection. So the edge should have more weights. And below is an example of our edge list. And by following the steps described above, we have constructed a huge network with more than 1,000 nodes and more than 8,000 edges. And the network density is really small, so it's a sparse network. And the average shortest path length is 3, and the diameter is 8, and the radius is 4. And we have also visualized the whole network using Gephi. And we also compute the centralities of our network and visualize them. And actually, that's the end of our presentation. And now we are still exploring our network, and I think we will have more interesting results in the future. And that's all. Thank you.
Okay, so generally, there are pretty many guys that try to adopt network science models to some kind of literature and some kind of cultural studies. Yeah, I remember, so at least several students and members of the lab tried to model different Russian classical novels by well-known Russian writers, and they have also modeled the communication structure of the authors. I'm pretty sure that there was at least one PhD defense about it. And as I remember, inside the HC University, there is the guy, I'm pretty sure he is somewhere from Norway or Denmark, something like this, who analyzed Hamlet with similar structures. Yeah, So the topic is pretty popular. The usual question of all these kind of cases is, okay, what can we see from this picture? How can we interpret it? Yeah, and generally, it's really so. It's very similar to these mind maps of actors or keywords that we have seen earlier. Yeah, because it can be used as some kind of supplementary descriptive material when you're giving some talk, and you see, so these guys are connected, so it's important, and so on. But it's not some kind of self-enough study. Yeah. Generally, the story really looks interesting, and as for me, I was very interested in the presentation. So thank you for giving this short description of the topic. It was really useful in this case. But the main question here is now what? So what we're going to show with these centralities. And frankly speaking, so there are two main ideas here, I guess. The first one is that the same authors may use some kind of similar strategies for the character interaction. For example, you can have a triangle where there is the hero, I don't know, the girl, and the antagonist, and they are challenging each other somehow. Yeah, and this is some typical structure that can be found in different books and that can be analyzed. So this is some kind of motif that you can try to detect from your network. Yeah. And frankly speaking, the main problem here is that your book is some progress where, so the story goes on, but your current model and your visualization is static. It tries to show the entire book in one snapshot, and this is pretty useless. I'm almost sure that much better and more interesting modeling can be done with by the means of temporal networks, and they were already mentioned today. And right now, it's very popular to analyze different traffic situations inside cities with temporal network models. They show great benefit of these tasks, but I guess it would be also interesting to try to model some literature continuous thing with a continuous story with these temporal models. I still don't know why and what can be found out by these models. I guess one of the possible questions here is that the same authors use the same strategies to add or remove characters and to just show this novel, and the temporal embedding can show it in a better way than the static one. So maybe these can be useful, but generally it's really hard to find good applications outside some kind of supplementary visualization. It's a big problem here. So you can either try to find some static motifs, or for example, take some chapters of this book and analyze communication networks chapter by chapter and try to see if you can describe some evolution process, and if you can model it, if you can say why this node adopted some connection or joined some community, or wherever it is, why it has left. So maybe this story would be more interesting. The other area where you can try to find something interesting, as I said, is try to Google if there are some applications of the temporal networks to the literature area. I'm not sure that it exists, but it seems that it may exist. So you can Google and see if there are some highlights there for you. So yeah,
what we are interested now is how much the book so as I have explained before, is a history-based novel. So the author has modified certain stories, and we are interested is whether the author has tactically defend certain people or groups, because as you can see from the the figure is Liu Bei. Liu Bei is much higher than Cao Cao, but in fact in history, the Cao Cao, this person is a main figure during that period.
Oh,
so he might, yeah.
In classical literature theory, the main hero of the novel is the person without whom the book couldn't exist. Yeah, and you can really compare if the author pays more attention and more description to some people.
Yeah,
and,
that's exactly what we want to do.
Okay, okay. So generally, I think that I can try to find those PhD theses about Russian book analysis, because you may try to steal some ideas from their research. And secondary, if you will Google if there are any temporal networks for literature discussion, this would be, first of all, interesting for me. Secondary, you may also find some good ideas and some models that can be used in your research. So my recommendation is all the same. Try to find some relevant cases where people have tried to adopt social network analysis to the literature theory. Okay.
Okay.
Great. So now gamers community, I guess. Dmitry Kuznetsov, Alexandra, Gleb, you're welcome.
Yeah, we're here. Wait a second.
No, I think now is an hour. We changed, I think.
Okay.
You have changed places?
Yeah.
Yes. Oh, sorry. Okay, Mikhail, you're welcome.
Here is.
I guess those who are still alive will be totally brain dead now. But okay, let's try.
Do you see my presentation?
Yeah, the World Project.
Yeah. So my project is about to apply some tools or strategies in social network analysis to find two neuronal, biological, or real networks. So so I collect the data from the site when there are many data about the connectome or the neuronal network of the C. elegans. It's the worm. It has about 300 neurons and about 6,000 connections between them. And there is many kinds of data there, types of neurons, the position of neurons, the coordinates of neurons, and so on. And my first step is to analyze the data about the position of neurons. So position, the kinds of position or types of position of neurons. So there is three parts: the body of the worm divided by three parts: head, middle, and tail. And there is the table. Then each neuron corresponds to some position, some part of the body. And I take this. I take two tables. So first table is about connections, and second table is about the type, and cleaned with data by intersection. So not each neuron classified by position from table, for example, of edges, and also cleaned by degree of 0. So by first step there was some nodes with 0 degree, and I also delete them, but not very many. It's still about 300 neurons after this cleaned method. Yeah, and then I first found some article. Then the authors do classification analysis. So they took some Laplacian eigenvectors and do the comparison or classification the position of these neurons by these two parameters. And you see on the picture, I think it's looks like good. So this here is 3 colors, and these colors corresponds to positions. Yeah, and so my key idea and description and methods that I will use. My strategy is, I call this strategy TCI strategy. First is try. I want to find centralities and try to classify neurons by them. It's a very obvious first step. Then check, see. I want to obtain the same results. So I want to see with graph that was done by authors of previous article. And the second, I want to improve. So I want to do better classification. I want to use, for example, a get method for graph attentional network method to classify with parts, so with types of neurons. Yeah, and it's just the first steps, because maybe I will do something like this to analyze another properties of these neurons. For example, take some types, take some classification of neurons by DNA or another things, and do some and apply some another analysis or the same analysis. I don't know. Visualization. Yeah, I said there is I visualize this network by network X library, and what I say, the number of nodes, it's about 300, edges about 6,000. For example, I color these nodes by position, so head, tail, middle, there is 3 colors and 3 types. It's just to visualize, just to see how it is on the network. Here is the statistical numbers. That diameter is 5, density is 1.06, and here is centralized distributions. I calculate with distributions for a directed graph, and in that case, I think between the centrality maybe it's not very good, because it's directed graph, and too many nodes can be not connected by directed path. So for example, for analyzing between externalities, I want to analyze the maybe undirected graph. I don't know. Yeah, and that's all for
great. So I'm really happy that you, at least for a while, gave up the idea with the organizational research, which was a bit terrifying. And this project looks a bit less ambitious, but it has very direct goals and looks like more than half of the work is done already. So the only thing left is just to train the graph attention network. So
not really. I think that after this training, if I will have some good results,
or rather bad results, and you'll need to fine tune something. And
yeah. If bad, it's also interesting. But if I will have some good results, I think it is interesting to apply this classificator of this position, for example, for another types of neurons. So,
are there any other kind of worm project data sets that could benefit from this kind of transfer learning tool? Because similar neurons should be also detected by the similar embedding patterns. Как эти дроздофил вот такую вот штуку не делали?
No. In other, I don't know how it's said in
English. Just another creature.
Yeah, in other creature, yeah, there is. I don't know the fully connected, not fully, but the network with all defined connections between neurons.
Yeah. I have an idea for you. You can try to explore if you add some noise to your network, for example, remove some edges because you don't see what's happening there. Will the classifier be able still to predict the label correctly? This is interesting.
Yeah. I think so. It's very good idea. For example, not noise, but I can also filter this network by some
by some condition.
A card or another, and
wherever you like, dynamic distance. And I think that this survey, if you'll get good results, is really publishable because other people who are doing some kind of neural biological research will benefit from the model that can predict the functional role of the neuron even without the clear picture of the entire creature.
Yeah, surely. It's very interesting indeed, thank you.
You're welcome. So I guess this is the very nice project. It's not very hard to do, and the idea is great. So Mikhail, everything is perfect.
Thank you.
Okay, guys. So can we move on? We stopped at the Game Geek community. So should we listen to the guys or should we go to the social media community migration? Daniil asks to jump tomorrow.
We can present Board Game Geek community analysis now if it's possible.
Okay, but Daniil, what is your topic? It's written in process at the table. That's great. Okay, so I will label you for tomorrow, and I guess let's move on with the Board Geek community.
Okay, give me a second. Could you see
Yeah. Daniil, can you please write the topic to the table, just not to forget about it?
Okay, I will tell about analysis of Board Game Geek community, about our project. And firstly, we need to introduce what's Board Game Geek community, Board Game Geek site means. It's the most popular, the biggest board game site where you can find a full description of any board game that was produced ever. And moreover, the Board Game Geek rating is the most reliable, most authority rating in the world, with quite tricky formula. Okay, firstly, let's introduce how Board Game Geek site works. There are games and users then which can express their attitude to particular board game via their rating from 1 to 10, from 0 to 10, I don't mind.
Sorry, just a small question. What about chess or checkmates? Or
I guess, as far as I know, chess also included. We can check.
I'm just interested. Yeah. I have opened the site, and it looks like it contains only some kind of card games.
Not only card games. For instance, you can see that chess is also included.
Oh, okay. Okay, thank you.
Okay, and if we go deeper, every board game has contains forums, different forums. For instance, reviews, rules discussion, or even play games, parties organizations to play the games. And each forum, for instance, reviews, contains threads where different users can discuss different topics. And what we want to do in this, the problems of the site is when you want to buy a new game, you want to track different posts, track different reviews in the internet, even in Board Game Geek site, and try to understand, will this game be necessary for you? Will it enjoy you after the buying? And lots of posts are misleading because people write very biased, people are subjective. And when you try to buy and try to understand, is it game necessary for you? You want to find the expert review, which are the most similar to your experience when you play games. And in this project, we want to find expert reviews, expert usernames, exclude biased reviews. For instance, some people don't like Euro games, a particular category of the games. And that is why their rating, their reviews were underestimated. We want to exclude them for players who like Euro games and find as an expert Euro gamer for these people for providing for given user. Okay, for instance, we have it's pity that we took very heterogeneous data. There are lots of types of nodes, for instance, board games, threads, forums, users, and so on. And we need to construct final homogeneous graph. And what I explored that we can create an edge between nodes, for instance, if these players express their attitude similar to this board game and write similar posts in one thread. That's why we will create a connection between these users. Okay, firstly, we need to construct final graph. To do anything, we need to collect data, and hopefully Board Game Geek provide XML API. And we need to write a client for this API. We wrote some client on the Python and did not yet collect user ratings because API is quite slow and do not allow to load very fast. That's why we already construct only without ratings, just the graph where edges created when users write in the one thread without taking into account ratings that these users put. And as we expected, the clusters, there is only one cluster, and in which game we, okay, for instance, if we take a look at graphs for each game, they look very similar. And to move further, we need to add information about ratings and exclude some nodes to see clusterную структуру. Sorry for Russian. And moreover, we want to analyze the whole graph, which is merged in a slice of different games. Okay, sorry for very скомканный рассказ. What I want to say is that even if we have a sparse user ratings, we can broadcast rating using collaborative filtering or use collaborative embeddings in some other way to take into account some embedded information about users and board games. Okay, I guess this is all, and I finish. Sorry.
Okay, so generally, this looks like the recommender system with benefits. Yeah. So I mean that from the very beginning, you have the classical recommender system where you can predict something like if user likes this and this game, maybe he will also like this game. Yeah. And here you want to add some additional weighting function that will use user rating in your ranking strategy and also some review information. Generally, this sounds pretty good, but a bit unstructured. So there are too many hypotheses that were mentioned and too many problems that are required to be solved. How to inject this weight, how to build connections between users, how are you going to model your final network and generate recommendations using GOT, or you want some other methods to build predictions. Somewhere nearby, there is a large area of some special kind of recommendation systems based on, another area where lots of network analysis is being done right now is dating services, because so in this case you will need not the recommendation of an object to a user, but simultaneous two-directional recommendation that should match. Yeah, and it's some kind of more difficult structure. This is not your case, but generally there are lots of models in this area that can be adapted to your case, just with removing this reciprocal recommendation. And it looks like your current state of the work is pretty good. You have data, you have network structure, but you need very carefully to pick some proper model somewhere near recommender systems or dating systems based on neural network models and try to adapt it to your data. So and this looks like a plan.
Yeah, thank you. Thank you very much. We will take it into account?
I'm not sure if this recommendation was really useful,
Yeah.
but generally, so somewhere in between, there should be some relevant article and maybe a GitHub repository with already created model. You already have the network, so the only thing you need to do is to adopt this model. Another problem that I see just from your current pictures is that it's very densely connected and some kind of core periphery. Yeah, and so that's not bad, but generally the best recommender model, but everything is connected to everything, is preferential attachment. And you can, if you think you can understand why it's happening, the most popular game is the best recommendation for guys where that will finally take everything. Yeah. So your network looks very dense, and it means that maybe you need some additional weighting function that will structuralize your network a bit better. Otherwise, you will have the situation where this dumbest preferential attachment model gives you better results than something like graph attention network. And it will be very stupid because you will spend, I don't know, days trading God and finally get the result worse than preferential attachment. So please be careful with your network structure. If everything is connected to everything, then you need to reweight your edges somehow to get structure, or you got it. Yeah.
Yeah, that's what we're thinking about.
And just as two more ideas, sorry, really check preferential attachment, because it's some kind of baseline that you should beat. And secondary, we're looking at your telegram with cats. Sorry. And secondary, since we're talking about recommender systems, maybe you should check some kind of factorization-based algorithms where you do PCA and recommend people things similar in terms of this PCA computation. Yeah, just as some kind of traditional recommender systems work. They try to make this metrics reduction and find common users, yeah? And this is another baseline for you. So most likely you should propose something better than traditional PCA and then traditional preferential attachment. Otherwise, the entire model is not very useful, yeah?
No.
Okay, great. Thank you for interesting ideas. Generally, we are not done with our seminar yet, but guys, you really surprised me. I was very upset with this year's students because almost all students that went to work on course papers and their graduation works with me were really lazy, and I started thinking that HSC is not so good these days. And all the time listening now is just something unbelievable. All the projects are very interesting. Some of them are just ready for publication. Others are a bit weaker, but generally the project level is very high, and I see that you guys are really working. That's awesome. That's sad that only 13 people can hear it, but guys, you're really very, very, very good students. Okay, so little break is over. Let's continue with the meta products prohibition.
Yeah, we're here. Good evening, everyone. One moment, I'm trying to show my screen. Can you see my screen?
Hello.
Yeah.
Can you hear me? Is already all okay?
Yeah.
Okay. You might be surprised, but it is not a meta. We have changed our topic, our research topic. Why we have changed the research? First of all, and the foremost, it is quite difficult to search and search information from the social networks or network that it is an extremist, which is an extremist organization. Therefore, we decided to change the vector of our research and turn to VK social network. And due to the last, I guess, event, as it was badly said, we have decided to investigate the different news states, news media, to investigate the filter bubble effect. For this reason, the name of our research is the filter bubble effect in the time of Russian operation, connections between opposition political groups in VK. So could you please, yes, next slide is the project.
Sorry, what's the Russian for this? Can you jump back? One more. Yeah, filter bubble effect. How can you translate it to Russian?
Это эффект так и называется, либо это эффект echo chamber, это эффект пузыря.
Okay, I got it.
Well, to start with, as you mentioned before, what is the filter bubble in Russian? So I can describe the filter bubble. This is the effect when users read by reading such kind of news. For example, they read all about the war. They feed from the VK or from different social networks will give you the information that is connected with the war. But if someone don't want to see it, that person will never think that the war is a problem or it is what now is going on. That is the filter bubble. The state of the filter bubble was, to make an example, more interesting example, is the bipolar political party in the USA, and there are two different groups of people who are reading only the liberal and others reading the conservators news, and this is the filter bubble. Well, therefore the object, could you please, yes, the object of our study was the filter bubble effect, and due to this, we take two VK communities. It's the Взгляд, and this is the magazine Doha. First of all, we want to make more bigger communities like Medusa and Russia Today to make more interesting research. But in these communities, there are more than 1 million subscribers, so our PCs went wrong. So we couldn't just aggregate the information. Well, for this reason, no, could you please slide back and another slide back? Yeah, for this reason, here is our goals to
was to understand whatever the media really make us make bipolar, and that is by collecting users in a table, visualizing, we would notice that the users are in no way connected with each other by the common communities. Well, then the instruments.
So here we used a parser called Paper Ninja to get an ID of the subscribers of these social medias. Then we use this list of IDs and filtered it in Excel, found the pairs that gave us information about the people who subscribe only on Doha or only on Взгляд, or the group of people who subscribe on both of them. And then we use this information to upload it in Diffie, and Nikita.
Yes. We have made a database of the user's ID and make it 2 data sets. First of them it's nodes and ages. In nodes we have ID and label. We guess that it would be incorrectly if we make names of the ID users who really watch these 2 communities, for each just a numeric identification, and the other one is the parameters where users subscribe in this network or unsubscribed on this network. And for this reason, we've got this graph, which you can see on the right. There are 2 clusters of users who are subscribed in these 2 publics. And due to this, we guess that, yeah, our purpose is reached. In this table, we can see 2 group of clusters, people who subscribe in Взгляд and people who subscribe in Doha. But then we saw a small centralic cluster, which is on the left of it, and this means that there are some people, some users are subscribed on both communities. We have 2 reasons for such small points of context, which are in betweeners. First of all, it's like Conover article that there are sneaky political neo-biases that spoke that it's just a standard outlier. And the second one is that their communities are too small. As I said before, it's about Medusa and Russia Today. For that reason, these publics are not as popular as the biggest one. Well, for that reason, we can see that the centralic position, the centralic cluster is not as big as we can have. And the next slide is what we will do next. We want to increase the number of public communities to get a better analysis. For example, in this visual example, we can see that there are more than 2 bipolar communities, and they are more closely connected than our previous ones. And this will give us a clear picture with the filter bubble effect in the realities of special operation. Well, that's, I guess, all for now. We go ready for the questions.
Can you please validate it? So you have a list of subscribers of 2 groups, and you have the information about their connections. And the connection between two users is the fact that they're friends with each other, or
no, they are subscribers of the same community. For example, the first cluster is all people of all IDs from this cluster is subscribed on the взгляд. The second one,
okay,
yeah.
I'm just thinking about some kind of relevant example. Okay, let's try the following one. Let's say we have two groups. For example, the first one is okay, I'll say it in Russian. Мы взяли две группы: садоводы за мир и военные байкеры. И оказалось, что между ними нет ничего общего. Из этого мы делаем вывод, что наше общество поляризовано и вот как бы делится на байкеров и садоводов. Но это же неправда.
Yes, да, это неправда.
No, look, so the first problem is that you're using the fact that people join some group as the connection. You're not taking into account other groups that those guys are parts of. Yeah, that's strange. So your criteria of the connection forming is very weak and very strange. Secondary, two those groups are really polarized, but they have different audience, because Doha is more kind of a student's newspaper. I don't know who is the reader of Взгляд. In fact, I have never visited this group, sorry, but generally I'm pretty sure that they are just grown-up guys. And even if they were not so polarized in terms of the current special military operation, yeah, they have nothing in common in their audience, because different people are interested in the news. They are not polarized by the attitude to this military operation. They are just polarized by their interests, by their current position in society, by their wherever it is. So we cannot make these kind of conclusions based on two groups analysis and based on the correlation if the person is the member of the group or not. We can pick just two random groups of contactee and say that there are very few intersections between them. It will give us the same result. And we can, in this case, we can say that each topic that we're interested in, I don't know, gardeners and crypto miners, is some kind of polarization. But this is not some kind of real fact that we observe from sociology, from data, where you're showing what you wanted to show. Yeah? Нашли то, что искали, а не то, что есть на самом деле. То есть это вот такое. So there are lots of problems with this model that you show. If I were you, I'd say that okay, you can pick two of those groups as your seeds. Take all their members, get all groups that they participate in, compute the distances between people based on all groups that are inside this model, and this will be a bit more legitimizing. but still, I do not like the criteria of the connection joining some group. Maybe I'm not sure that this is still correct. Maybe this should be analyzed. Maybe we should use just common friendship. So because when somebody is polarized, it means that people are not talking to the guys from the other group, but we cannot be sure that they are not talking if we took only two groups or if we took all groups. So this is still a big problem. For example, I don't know, I have a colleague that's maybe very, very, very interested in Vzгляд, and we talk every day. Yeah, it's not the problem for us to talk. We have different interests, but we respect each other and continue our communication. So I'm sure that this is some kind of polarization effect. You see?
Yeah.
I'm sorry, maybe I was a bit rude, but you really need to redefine the methodology of your research hypothesis, of your entire research. Talking about the data, so spoiler alert, I have a dump of entire Vkontakte. If you find a flashcard big enough, I can just write this data for you if you say which groups you are interested in, or we can use some cloud wherever you like. Yeah, because if you're throttling on data scraping, I can help you with it. But generally, you cannot make those kind of conclusions based on two groups.
Yeah, we agree, and it will be great if you will help us with the data, and we will work on our methodology.
If you're in Moscow, the best thing you can do is just to visit me with your laptop, because it really will take some time to filter it, and it would be much more easy if I'll just give you access to the database and you'll pick the records that you need. Yeah, it will be just simpler and quicker rather than you will wait for me to do this job and to filter it for you. But first of all, so you need to take all these users that you're interested in as a list and send it to me. I guess I can get their groups pretty quickly.
Thank you.
This is some kind of first step. But in this case, you will still be too limited because you're analyzing only subscribers of two groups. Maybe you need the second and the third round of connectivity to see the real structure. Yeah. So, but the second round of connectivity from Vzгляд most likely leads to almost half of the Vkontakte, because as I know, it's a pretty large group, as well as Docker. So, and the real answer, if there is some kind of this filtered bubble, can be defined if we will analyze the entire network and everything that is between two those groups. Yeah, maybe they are not so far. Maybe they are far away from each other in terms of the entire graph. Maybe they are very close because somewhere around them there are lots of topics where people are very far away from each other still. Yeah. So, but your current conclusions are very, very, very rough. Okay.
Yeah, we get it.
Yeah, okay. So, but the main problem here is still that lots of data needs to be analyzed, and you need some tools better than networks if you want to continue this research. At least try to shift from networks to iGraph, because it means larger models. I guess so. These are just main recommendations. And since we have jumped to the larger data set, there will be a question: how will we answer if there is this filter bubble effect or not? We need to think about it again. I guess another good option that you may benefit from is try to talk with some sociologists that is specialized on online network analysis. Maybe someone from our lab or wherever it is, because I'm not a sociologist totally, but since I've spent some time speaking to them, current hypothesis is really something that will that sounds very, very rough. I guess the best option here is to try to talk to Ivan Klimov, because I guess he will have some methodological recommendations in terms of sociology for you. And if you're interested, I can ask him to join one of our consultings and to talk to you and give you some recommendations if you want to make some kind of proper, good framed research. Okay?
Yeah.
Super. Just write me what are you waiting from me in Telegram, because unless you will ask that you need something, I will not do anything. Yeah. So if you decide that you need some data, write me, here is the ID list.
We
send
get
us some data. If you decide that you need the expert consultation, just write it to me, because I will not do anything unless you push me. Okay.
Yeah, we get it. Thank you.
And thank you for presentation. Duma lawmakers.
Yes, hello. Hi. So let me share my screen. And no. Okay, so please confirm if it is visible and it is full screen. Okay, thank you. So our theme is analysis of Russian Duma lawmakers and their participation in legislative process. I did the data scraping, and Maxim Todinov did the data analysis and visualization. So before we go into any details about our goals, let's start from a background and like what Duma is. And basically we need like 3 little facts about it. Members are elected and they're called deputies. Deputies can create laws. And Duma consists of different formal and non-formal factions. Let's get to the Duma structure, because that's what we're interested in. So Duma consists of 450 deputies, and here they are spread, not like spread, but you know, like they are in different parties. So the elephant in the room is the United Russia, because it takes about 2/3 of the Duma. And which makes it a constitutional majority. So basically they can create any laws or anything like that, or they can decline any laws, just like that. But at the same time, as Vyacheslav Volodin, the vice speaker of Duma, said, about 48% of the new Duma, the 8th convocation, I believe, are newcomers. And also there are other factions, like there are 32 committees and like 5 commissions in Duma. So yes, we are interested in, like what kind of communities already exist and factions already exist in Duma. And the last part of, like of the background that we are going to need is co-sponsorship. So this term is, like when two deputies or legislators want to create laws together. So they're like, let's make laws together, and they create a law. So they are co-sponsorship. So yeah, now to our goals and questions that we have. First of all, what parliamentary coalitions exist and on what basis they are they're built? So is it, like something formal, like United Russia, or newcomers, or something else, or they're more informal, or oh yeah. What is the overall degree of legislative co-sponsorship in the current convocation of the state data Duma? You know, like, yeah. And is there a correlation between the deputies' credibility and co-sponsorship? Now, this is where we think this will be more like an additional goal, but the idea here is that like when you are a legislator who basically your vote either makes the law, either creates a law or declines it when you participate or not participate in creating a law. So yeah. Part 2 is about scraping the data. So first of all, we would need to understand what kind of data we need. And we would need, and what we have, right? So we use as nodes, we use a list of legislators, and their factions as their attributes, like party and committee and commissions. And we need to have a list of laws as edges. So let's start from laws. It was actually pretty convenient how it is done. So we have this pretty site that's called Source Duma Go Through, and it has a pretty nice interface where you could download a lot of the laws with sub-Z, what basically is the legislators. That means that the people who initiates the law or act or something like that, and they have the act. So as we wanted to analyze what happens, what already happened, like either the law was declined or published and accepted, confirmed. So we only took the laws that were already in archives. So that basically means that either they're declined or approved. And legislators, it was a bit hard to find the relevant ones. So we did have to scrape the Duma website. So we scraped the list of legislators. For all of them, we scraped their name and faction, like United Russia, and other factions like committees and commissions. The final data for legislators looks like this. It's their name, their faction, committee, and commissions. Note that it is an array, so there could be more than one commission for political figure. Third part is analysis. So out of the scraped data, we created a distance matrix where number displays a number of laws that were created by those deputies together. Like Alansky and Greshnikov has 2 laws that they did together. And this is our visualization, the graph that represents it. I just really like it. So, and here are some of the
what was
measures.
the tool for the visualization?
Maxim,
Pavis.
Can you send the link, because it's unfamiliar to me?
Yeah, it's just I don't know. It's like
PyWiz. I got it. Yeah.
Yeah. PyWiz is like a really popular visualization tool for graphs.
Surprising. Thank you.
Okay. And here are the network measures. So we have about 108 nodes. That means deputies. And keep in mind that it is out of 450 deputies at all. And there are about 492 edges in there. And average degree is 9. And here is the between the centrality. So like note that is the central node is a very interesting one. So it turns out it's like Oleg Nilov, just the fact because he's just very curious about to see who wasn't there. So yeah, I think that's it. Of course, there are some limitations here where we're only focusing on deputies, but you know, there are some other legal entities who also can create laws like court, government, senators, etc. There can be other co-finders like region and other characteristics of deputies that were hard to scrape. And of course, the list of deputies might change over time due to deaths in case of Zhirinovsky, for example. And the of course, the convocation is far from being over. So, like the found coalitions will change over time. So it's just like a small snapshot of what happens. So I think that's it. Yep. Comments, questions?
So the picture is really great. I guess we should include this to further courses because it's pretty readable. I still have some questions about the coalitions, because do you think that committee membership is correlated with coalitions? Maybe everything is vice versa, and guys that have the opposite opinion are participating in this lawmaking process. Because, so for example, I want to restrict people walk on the streets after 7 o'clock, but the other deputy says that no, this shouldn't be done, and he's taking part in this committee. No.
So yeah, so the idea is like we don't really know. So we have to analyze it further whether like the committees are relevant here. So for example, these 3 no's are from Justice Russia deputies, so they're not like from United Russia. So it's like it's not really it's kind of counterintuitive, because you think that United Russia is like this huge repression thing, or not repression, or just huge thing that can do anything. But like it turns out that there are other people who actually do something. I don't know, maybe this thing is committee, but we don't know it. So yeah.
Yeah, Professor, what is you mentioned is exactly what we're looking for and what we're trying to find, because the Duma convocation is a really complex structure with a lot of, as you mentioned, I don't know, with a lot of psychological moments on how to deputies organize themselves together to make laws. Yeah, and this is our attempt to find something interesting.
I guess this work would also benefit from some kind of expert consulting, but generally just looking at this theme, I would recommend 2 following steps. The first one, I guess we should differ the committees that whose laws were some kind of accepted by majority, and votes where there was some kind of discussion and even inside the United Russia. Yeah, because I'm pretty sure that there are enough laws that are not politically polarized, where the United Russia makes one single solution. Yeah, and where they act as individuals that lobby, I don't know, some interests. Yeah, and the real interesting thing is inside the analysis of the laws where there is some kind of not the majority vote. Yeah, and this should be the most interesting block. And if you exclude all votes where the entire Duma, or at least the United Russia, voted similarly, then you will have different picture. That's the first idea. The second idea is that there are lots of research on block modeling and on signed network analysis of the United States Congress, where they have joined and labeled the deputies not based on their work, but based on their voting strategies. And maybe some methods from this area can be borrowed in your research. The third block is the third idea relevant to your research is that there is a lot of game theory inside those processes where you know that someone will do this if you will do this, and so on, so on, so on. And as I know, Liskerov was developing some kind of voting models for different parliaments and based on game theory. And maybe you can also ask, discuss this project with someone from his lab and get some feedback. So these are three main ideas what can improve your current project. Generally, so you need to highlight your goal more kind of more clearly. So the idea to analyze Duma is brilliant, but so what is the final research hypothesis? What are we looking for? Can you repeat it once again if I missed it?
Yeah, so the idea is to see whether the formal factions like United Russia, committees, commissions do actually matter, or they organize themselves in a non-formal way, or just like in a way that they know each other, or that is not very just not non-formal way. That's
so
not
you mean
real.
if the committee formation is driven by the fraction or not? Is this the research hypothesis?
So, well, for example, we have a group of people and we know to understand like what really makes them. What is the majority?
The informal group, and the group is the committee. Or okay, another case. Why I don't know, Sablin, Karlov, Lebedev form some kind of community in terms of the committee. Do they support each other or not? Yeah, so this is kind of research.
So basically, like, the idea is to look at them whether this cluster is like it's like from one fraction, like one political party, or is it from one committee or commission? So if it's not, so if it's just a random people, basically, so
it looks like it doesn't, because we can clearly see that there are
we do not know.
No. Just from this picture, we see that there are four closely connected communities, and this doesn't look like some random process. Most likely, if you have a look at the laws that these committees have produced, they will be in the same field, maybe. Yeah, but surprisingly, we have something like almost 500 deputies at the parliament, but your current map is something containing less than 100 nodes. Yeah, exactly 108. Yeah, I'm just surprised that all the rest of the deputies are just I don't know, doing nothing.
No. Once again, it's like archive problem law. So maybe they did propose something, but it was maybe it is in the process, or anyway, the convocation is just about like 1 year, so it's okay if like all of them did created something. So yeah.
All right, Professor. As I understand, we should define the way that deputies make the groups, right? Of themselves.
I guess this is your idea, but generally,
yes.
I'm really a bit afraid to give you some sociological or politological advices. It's better to again, I don't know, Dima Zaitsev, Ivan Klimov, both of them can give you some kind of good consulting about this. Should this be taken into account or not? Because they are expert exactly in these areas. I'm not an expert. I don't know if this research is worth doing or not. I can help you with some tools, maybe algorithms. As I told you, there is an implementation of HITS algorithm for community detection based on voting, and it shows pretty good results. But I'm pretty sure that it's not the case for the Russian parliament, where you have the majority of one fraction. Yeah, because it doesn't matter how you vote if there is the majority. And your research looks interesting to me, but you should validate it using some experts. So my main recommendation is all the same. If you want to make some kind of resultive work that would lead to some new knowledge, you'd better discuss it with a political expert. Yeah, and there are some. So the same was with the previous guys. It's better to take some consultation. I guess.
But it's interesting that more respectful, as we can say, deputies, they not from the party of power, not from United Russia. They from how to say, Справедливая Россия.
Okay, generally, so the recommendation
so it's interesting.
is still the same.
Yeah, there are three big like sharks, and around them a lot of small fishes that from a lot of parties and so on.
Okay, so
yeah, let's wrap it up and let's make some room for other people. Thank you.
Yeah,
for your feedback.
yeah, because people are dying just right now. So we have three speakers left. That's great. Climate change is the next one.
Yes, it's my turn, Professor.
Sorry for being really late. I'm very bad moderator because I'm too interested in your results. Okay, so you're welcome.
One moment.
So if you're speaking, we don't hear you because you're muted. And still muted.
Now?
Yeah.
Okay, nice. So the main idea of this project is to analyze Twitter data at a specified time period about the climate change sentiment, and particularly people's feeling. So about the primary goal of this project is to focus on the link between the environment and climate change by gathering social network analysis of climate change with sentiment analysis.
Super.
So here is how we collect the data. First of all, I collect the data using our program through the Twitter API, and the target variable, it goes the climate. Also, the time period of tweets, it goes from May 26 yesterday
until today, May 27. It was this because this is a few days before the Global Environment Day, and I would like to see how hot topic it is, and how people feel about this day. So the main steps in case to collect this data are, first of all, create a developer account on Twitter. The second one is set up our environment, and the third one is use the search twist function to collect the data and save this data. So this is the data analysis, and I set the node to 100,000 observations, because this climatic world is very popular, and I would like to limit it. So here I collect this amount of observations, and here is the total of observations and the variables of this data, and some of the variables is the status ID, and the third one is created at. This is the date of this tweet, and so on. So thank you.
Sorry, once again, traditional question.
Yes.
Where the social analysis starts? So what will be the social analysis, the social network analysis?
I didn't have many time of this, and I'll gather only this data, and I will do this data analysis in the following tasks.
No. But what is the design of the network? So are you going? How you are going to create your network? Will it be the network of users, the network of topics? What is the idea?
Okay, the idea of this project is to analyze the people's feeling about this day, this World Environment Day, as I said, and to comment this feeling.
Yeah, but look, analysis of social network is not social network analysis. Can you see the difference?
Yeah, I can see.
So I mean that at our course, we are focused on applying some methods of social network analysis to some areas. And one of these areas is online social network like Twitter. Yeah. You're going to analyze so users' attitude to this area, but okay, you can just say that let's compute sentiment and see how many positive and negative tweets are there inside your data frame, and let's do some kind of clustering thing and see if there are many or few clusters there, if people are talking about different things or about the same one. Okay, this is good, but where social network analysis starts, what are we going to do from that social network analysis? Because all the thing that I have mentioned is something around NLP, yeah, or information retrieval, if you like. It's not about social network analysis.
Yes, but I would like to do them on the next tasks, all of them. because I was confused with this task a little bit. So yeah.
Formally, I can see that you have found the data set, but your current position is a bit risky in terms of while going in depth with your analysis, you may find that you need some more data to make the proper analysis, to scrape something else, to see what else these people are talking. So you need to formulate your project, the steps that you are going to go further as quickly as possible, because otherwise it will look like you have spend a lot of time scraping data, but you still don't know how to analyze it in a proper way. I mean, not in the terms of NLP, but in terms of SNA. Yeah, you really need to find out how you're going to analyze this data with social network analysis. And right now, you cannot answer this question. If you need to talk about it and to verify some hypothesis, so once again, consulting hours, I don't know, private messages, let's try to discuss it, but you need to figure it out as quickly as possible, because otherwise you will have the data without the research hypothesis. Or not kind of research hypothesis. I understood what you're going to understand. And in fact, it's pretty close to some kind of previous speakers that talked about what those guys are talking about, what HSC students are talking about. As I remember, it was the 10th or the 11th report. So you can borrow some ideas from Vera or Polina, yeah, and try to adopt their ideas to your work. So you can do this kind of analysis, but you need to formulate it better. Okay.
Okay. Yes. Yes.
Super.
Thank you very much.
You're welcome. And cyberbullying.
Yes.
Ekaterina, you are dying.
Yeah, alive, but at what cost? 1 second. There is this Zoom bar that's very annoying. Okay. Yes. We only two of us, so we don't have a link to the chat. Yeah, here you can see the roles of us. Wait, I'm sorry, maybe I am dying a bit. I need to collect myself. Anyway, let's start with data first. I found data set that contains tweets with hateful speech in them from Kaggle. It was already used in the paper, but I think the authors didn't, I mean, they did obviously a very good job, but there are some things that they didn't do. For example,
totally bad job. I guess I know this data set. Yeah.
Yeah. Okay. But in the
as
end,
I remember, they scraped Twitter based on several words like nigger and something else. And this is not the proper way to find hateful speech. But okay, sorry.
Yeah, I also have questions to it because hateful speech is not cyberbullying, and seems like, yeah, their classification was also not that good. Well, that's where we come into the picture, hopefully. So the data set has 47,000 listed totals, 6 classes, and that's how it looks like. Key idea of the project is to explore words and patterns associated with each type of bullying through graph for exploratory data analysis, and also using graphs to predict the type of cyberbullying, or if it's cyberbullying at all or not. And also, hopefully, I would like to answer the question, what makes hateful speech cyberbullying? And also, we do have a goal, like the idea of the project, maybe it's a bit vague, just a bit, but also just want to try a lot of new learned methods that consist of graphs to see how they work and what they can do. Yeah, and obviously, cyberbullying is an important topic nowadays because there are a lot of sad times that happen, and social media like to censor things. So for example, if something happens like school shooter, then maybe data scientists at Twitter should be prepared that now they have to censor a lot of tweets that have to do with religion or racism. So we have one goal to perform clustering based on semantics of words on the streets. And yeah, this is what probably we're going to do. And also we have a goal B. If I will be able to understand how it works, then I would like to try doing the graph neural network for cyberbullying classification. For that, for both of these goals, we have to first prepare data, which we've already done. We removed stop words, special characters, hashtags, and emojis are under the question because they might carry an important role to understanding if it's cyberbullying or not. Prepare text graph. Now we have one graph that is based on frequency of words. I'm not sure, I'll show it to you later. I'm not sure if it can be called bipartite structure, but it's based on bigrams. And yeah, we have to train the model. Yeah, basically I've discussed what we have. Are you upset with the presentation or is it a
bit?
Oh, okay, well, yeah, so we have network that we did visualize by the end when R finally started working. It looks like this, where nodes are unique words, ages are bigrams, so frequency of a word combination, and yeah, word one, so the source, word two is the destination, so it's directed graph. Yes.
Okay, so it's some kind of something very similar that we have seen at the very beginning of our today's seminar, because you guys have also visualized some kind of word map and tried to exploit it for some kind of predictions. So generally, it sounds okay. I mean that, yeah, this kind of research can be done, but I guess the real, I would do this research in a bit different way. So I mean, why are we clustering texts at the very beginning? So why we suppose that clustering detects some kind of proper artifacts that are relevant or somehow connected to the cyberbullying that we are looking.
I think clustering would be more useful than supervised classification, just because we can do it when we don't have a lot of data, and it's like we don't have a lot of annotated data. And also clustering maybe in type of like topic modeling, where we can do soft clustering and yeah, detect types of cyberbullying by topics basically. And also see, so sometimes it's not very obvious, or where like sometimes there are some things that fall between different topics, right? So we could see how they connect. Yeah, I basically studied computational linguistics, so maybe I'm thinking about it in terms of like philological research and literature research, but that's how I see it for now.
You know, I've spent 10 years, already 15 years working in computational linguistics. So your point of view is very, I can understand your point of view.
Yeah, but I'm just starting out, so.
I have built tons of those visualizations, yeah. But generally, so my, I don't know, belief at my current moment is a bit nihilistic in terms of computational linguistics. You do not need networks to see these connections, because if you take your clusters and extract some kind of most important words or most important predictors, for example, using sharp, you will see the same words, yeah? And there is nothing to do with social network analysis in these tasks, because usually those algorithms give you some kind of better results, yeah? This is a nice visualization, because you see that some words are occurring together, and it means it encodes the topic somehow. Yeah, black, Negro, white. So I guess this is some kind of skin color. Another topic is the story about the religion, bullying, and sexual orientation, and so on, so on. Yeah. So this is the nice map that shows you some trends in cyberbullying, and this can be done using these NLP-based methods. For example, just cluster description, yeah, or SHAP, or something like this. Or it can be also done with networks, as you have did it. But and then please don't be upset, because that's okay. In fact, looking at this picture is pretty interesting in terms of qualitative analysis. Yeah, we see what words are important. It gives us lots of information. Yeah, you can describe the entire cyberbullying area with one picture. This is good, but the thing that, so your project could be much more ambitious. I mean, do you remember when we were talking about embeddings? I have shown you very quickly the paper about something similar, the hate speech. Yeah. So
yes.
they have made some supervised classifier that detected this hate speech in comparison with the ordinary speech. And of course, it wasn't good, because so it missed lots of words. Yeah, it wasn't pretty good fine-tuned. But if you will take something like 10% of the most strongest predictions done by this classifier, I'm pretty sure you'll really get hate speech. Yeah, there is always some gray area where it makes mistakes and doesn't understand the context. But 10% is definitely the hate speech. And then you can try to see if you can use network information to predict users who are hate speakers. Do they form a community? Are they close to each other? And if this happens, then you can extract a lot of information from it. For example, you can take all their text and cluster them and see what else they are hate speaking. Yeah, you can say that hate speech prediction is the task not only for natural language processing, but for simultaneous SNA and NLP areas. And joining forces leads to better prediction, because many hate speakers form social network groups. And this sounds much, much, much more ambitious to me. And this is some kind of thing that I would really enjoy listening. Yeah. I don't mind about this visualization, but I still don't know if it's proper time to change project to something much, much more complex. But that's why I was a bit upset. Yeah, this is the idea. As for the current research, so okay, you can detect communities and highlight the areas where this kind of cyberbullying happens, yeah, and try to discuss it. But this still looks like a bit too simple research, especially in comparison with this report about, and now spectral temporal graph neural networks for multivariate time-series forecasting. Yeah, Anastasia and Nikita, they have made, they are going to make something amazing. Yeah, it will be something very complex. And here we're just doing community detection. It would be great if we find some more insights and maybe some additional work that can be done here.
Mm-hmm. Yeah. Okay.
I'm so sorry to give you this kind of negative feedback, but
I might cry myself to sleep, but it's okay.
You're just tired. So it's still a good project, yeah. But I'm just thinking that it could be much more interesting. Yeah, that's the idea. And if I can help you somehow, if you change to make it more kind of difficult in terms of scraping data or kind of training this supervised classifier, we may talk about it. But in fact, so I'm still not sure that it's a good idea, because really it's the 27th of May already. Yeah, and to start with the very beginning, extracting social network information is really very expensive. So something quick can be done from Reddit and from Contact. Yeah, those sources can be scraped quickly. Since you are working with English data set, maybe you can try to use this data set from Kaggle as some kind of sampling that can be used to train the supervised classifier. Because there are lots of root words there, yeah. And generally, I'm not sure if we will detect the cyberbullies. We will just detect the root speakers. But I don't know. Maybe we can filter them somehow using your current map. For example, if someone uses these root words and some religion topic or sexual orientation topic, this is most likely cyberbullying. Most likely, this is not everything that happens in the internet, but if you will try to adopt your current data and try to train this classifier model, and then jump to the social network structure, for example, of Reddit, yeah, this may be useful. The main problem with Reddit is that it's highly moderated, and I'm not sure that there are lots of those cyberbullying texts there. Yeah, so it's being cleared very quickly, and most likely we will not just see them a lot. So this is the problem. As for Contact, everything is okay with it, except it's a Russian network, and no one in the world is interested in analysis of the Russian network. We love bots that is dying already, because so everyone who are talking at Telegram and I don't know, wherever they are, TikTok, and so on. So it's still a good project, an interesting one, but listening to your ideas, seems like you could do a more interesting one. And I guess this is also my fault, because I didn't give you the feedback about your proposal in proper time. So, but if you still decide to make some kind of more complex analysis, just give me a note, and I will do my best to help you. If you will not, if you'll decide just to finish this fucking course and this analysis, it's also okay, because so the current project is also good.
Yeah, but I mean, finishing course is one thing, and another thing is maybe doing proper research later. I mean, after, not after, but when the course finishes, like the research doesn't necessarily need Yeah.
This is also a good solution. So just
Yeah.
give me
Okay.
a note
Thank
in this
you.
case.
Yeah.
Okay.
Yeah. Thanks for your
Super.
interest. Good night.
It's my wife's birthday today.
No. Okay. Well, one
Okay.
more person.
One more person.
Oh, yes. That's why I will be fast, of course. Digital, it's digital transformation. This project is aimed to study the topic of digital transformation in scientific community. If the current field of knowledge began rapidly in the past 20 years, and that's why I suppose that project will contribute to better understanding of field of knowledge of digital transformation, in particular which communities should be monitoring now, how trend sets and who support them, and which main trends, main themes, concepts, and how they assimilate in this network of knowledge of digital transformation. Main steps of this project, it is of course it's a literature review of bibliometric analysis. It is a lot of information. Of course, it is a list of main references, and the main problem it is collect data from these scientific databases. After collecting data, it's preparing data from to the network analysis, and of course bibliographic networks. When I read a lot of information about bibliographic networks, I understood that for the choose main titles, main articles of this knowledge, of this field of knowledge, we need to use some different network analysis, bibliographic analysis. That's why I have choose the main and the at least analysis of this network, bibliographic network, where I find the main articles, the main base. After that, I will use a topic modeling like LDA, maybe something else. And after this, I will check how this topic and trends assimilate in networks. The algorithm I don't choose, but I think it is maybe I don't know now, but I will not answer now. In which stage I am now? If I said the main problem is to collect data, and now I supposed to collect data from Scopus, because Web of Science it is restricted, and I try, but I can't do anything with Web of Science. With Scopus, I try to with API, but it's another problem. And now I retrieve data from a lot of time waiting, like a CSV, like a traditional method of CSV. And now I have a data set of this kind of articles. I prepared this article for network analysis, and in this stage I am now. I think that's that's all.
Okay. So, am I right that you're going to analyze some kind of trend being trend that the network adopts, yeah, where you start from one node and then another node adopts some trend, and your current trend is some keyword, for example, I don't know, graph attention networks, yeah, and your nodes are researchers that are adopting this trend by including the keyword to their publication.
Yes, the trends. If I right to understood that you say, my trend will be include the keywords or some words with which choose the topic model of the key.
Super. Two questions. Yeah. First one. Why don't you use the keywords just from the articles? Why do we need topic modeling to detect them? Because maybe just keywords inside the articles will be enough.
A lot of authors give keyword.
Okay, there are only 4 persons in the room who can speak Russian.
Ну, очень часто получается те слова, ключевые слова, которые дает сам автор, они не являются того, что он описывает. Вот это часто встречается в публикациях, особенно последних. Вот. И
the second question. I'm pretty sure that research community has published something around at least 400,000 articles in the previous year. You have downloaded 46,000 articles from Scopus for the period of 2 decades or 3 decades. How can we be sure that this sample is some kind of representative?
Because digital transformation, it's not it's new sphere, and if you can see on this this picture on the last years, maybe I will use Temporal network something with time, and this will be another. This is a big tail will be not representative, but
can we? So, how have you extracted the articles about digital transformation from Scopus? What was the criteria to scrape them?
First of all, it is keywords. It was main keywords, and it was some authors, because they don't use keywords, but it's this the main is keywords. Keyword digital transformation, some changing and other. It's with там мы обсуждали это с научным руководителем, я как бы по кейвордам отбирал это все. Вот.
Научный руководитель.
Там получается Багратиони, один из, Константин Миронович Багратиони есть. Он занимался как раз этой цифровой трансформацией, сопротивлением изменениям, цифровой трансформацией, всем этим. Собственно, я про это и спрашивал.
Okay. Okay, so in fact, my current recommendation is very similar to the previous speaker. Yeah, generally, everything looks pretty fine, and I can see that you have thought about the ideas of our consulting, about journals, universities, no, there are no universities, but maybe you should include them also. There are several bipartite networks, yeah, and they can be analyzed individually, independently. Still, this research would really benefit from two main limitations, or not kind of limitations, for two main recommendations. Yeah, here's the right word. So the first recommendation, I may be totally wrong, but our current course is around social network analysis. And to my point of view, keywords mentioned by author are quite enough to detect some kind of trend following. Yeah, this is not the precise and the accurate way to do this, but nothing in terms of social network analysis will change if later you will replace the author keywords by the LDA or wherever it is keywords. By the way, if you're interested, recently I have seen the paper about topic modeling with BERT. Yeah, and it's very promising. So maybe you should replace LDA with BERT. But generally, nothing will change in terms of social network analysis if you will do the research based on keywords and do not waste time on LDA and filtering the final keywords. I just highlight that if you will not do it quickly in a week or at least 10 days, then you should stop doing it and continue working with social networks. Yeah, because our current course is about social networks, and I want you to work more with social network tools and methods rather than natural language processing ones. So please be careful with NLP and do not waste too much time on it. Okay?
Okay, understand.
The second point, and you can easily replace it and do the proper analysis later. Yeah, and when you will not be in a hurry. The second point is that your current keywords and your current trends are very, very biased by the search strategy. To see the real picture of this digital transformation, you need to scrape all papers of all authors that are inside your current sample. So if someone has mentioned this keyword, it would be pretty fair to download all his articles and see what else is there, just to make the better network. So maybe there are connections between the authors of your network that you do not see because you are using very limited list of keywords. Is it clear?
Not at all, but
okay, let me show the example. У Ильи Андреевича Карпова есть статья про кино, как мы сегодня вспомнили. Значит, он, наверное, там, усвоил тренд там заниматься кино, да? Но вопрос, от кого он его усвоил, совершенно непонятен, потому что половину статей, которые вот есть у авторов вокруг, с другими соседними ключевиками, мы не видим. Статьи других авторов и статьи самого Ильи Андреевича мы тоже не видим. Мы только одну собрали. И мы довольно так условно можем прогнозировать, распространяется тренд по сети или нет. Мы в реальности всю сеть не видим. То есть, как бы, вот у меня есть круг соавторов. Вы его не видите, потому что большая часть круга моих соавторов, она, вот эти ключевики, скорее всего, не использует. И как бы это вам немножко искажает анализ. Вы, как это, искать под фонарем. Почему искать под фонарем? Потому что там удобнее. То есть вы смотрите только авторов, которые и так уже вот активировались, а авторов, которые не участвовали в активации, вы вообще не видите. И поэтому, как бы, естественно, вам как бы алгоритм подскажет, как в вашей текущей сети тренд распространяется. Но как бы реальная сеть от того, что вы сейчас видите, очень сильно отличается. И поэтому алгоритм, который хорошо работает на сети активировавшихся авторов, будет ужасно работать на сети всех авторов. Так лучше? Супер.
И главное это использовать алгоритмы на всей сети, правильно сразу?
То есть вам для того, чтобы видеть реальное распространение, вот авторы связаны, а оно не идет. И алгоритм это должен моделировать. А если вы видите только авторов, которые согласились распространять этот тренд, то он у вас становится очень сильно biased.
Смешно.
В общем, вот как бы у вас biased network получается. Для того, чтобы это исправить, самый простой способ – это, опять же, забить на скрейпинг с фокуса, либо докачать все статьи этих авторов и всех их соавторов, что вас загонят в полную задницу с дедлайном, либо все-таки попытаться посмотреть вот тот же самый тренд, но на сети архива. Как бы архив просто дает дамп, который можно взять и не париться. Вы возьмите как бы данные, то есть примените те же самые ключевики к архиву и возьмите оттуда буквально статьи, абстракты которых там эти ключевики упоминают. Это сделать сравнительно несложно. А с точки зрения сети возьмите все публикации архива, по крайней мере там авторов и соавторов авторов, которые вот у вас как бы участвовали в распространении. Либо вообще весь архив взять, либо взять какой-то там окрестность авторов, участвовавших. И тогда у вас не будет проблем с этим смещением. В общем, если распределять свои усилия и выбирать между правильным отбором ключевиков и правильным фреймингом сети, то я, как человек, который вам подает сетевой анализ, всячески рекомендую силу потратить на то, чтобы фрейминг сети нормально сделать. Если у вас это, опять же, в течение 10 дней сделать не получится, бог с вами, сделайте хотя бы на тех данных, которые собрали анализ, и я вот так вот скажу, что, да, человек постарался, что-то сделал. Хотя с точки зрения там научного ценности у меня большие вопросы будут к этому исследованию. То есть это okay for the course paper, но если бы я был рецензентом на конференции, я бы вам сказал, что так делать нельзя.
Да, я понял.
И я вроде объяснил, почему. То есть я боюсь, что вы сейчас очень много времени потратите на лингвистику, а с точки зрения сетей у вас будет все не очень хорошо, потому что вот там есть другие проблемы, на что надо потратить время. И в этом смысле Scopus, я боюсь, что вы его не успеете собрать вот так, чтобы эту проблему решить. Поэтому советую вам попробовать посражаться с архивом. Если вы в течение недели поймете, что там этих данных в дампе нету или что вот вас по каким-то причинам не устраивает, опять же, у нас все-таки курсовая, а не диплом. Поэтому я вас, конечно, прощу и не буду за это дело топить. Но, пожалуйста, попробуйте все-таки сделать все как надо.
Хорошо.
Ура. Глобально, что делать дальше, какие метрики использовать? Вы строите либо модель эмбеддинга, influence propagation, какой угодно считаете. Хотите инфтувеком считаете, хотите temporal гатом считаете. И то подходит. Инфтувек просто учится быстрее. Хотя не факт. Можете использовать простые threshold модулы из лекции про эпидемии, которые вы использовали. Они как бы тупенькие, но хоть какое-то простое моделирование вы ими сделаете. А вот то, чтобы оно хорошо работало, то есть как вообще проверить, что ваша сеть правильная? Вы обычно что делают? Обучают сеть, перевзвешивают в ней веса так, чтобы вот эти threshold модели тупые, они правдоподобно распространяли по сети информации. Если модель независимых каскадов или модель усвоения тренда в вашей перевзвешенной сети вот просто случайно активирует и дает результат, график активации, похожий на то, что вы наблюдаете, значит, вы правильно перевзвесили сеть. И вы понимаете, какие авторы на самом деле сильнее связаны, а какие нет в терминах распространения тренда. А это буквально то, что вам нужно. То есть правильный путь вот такой. Но это прям вот такая задача максимум. Я надеюсь, что вы там успеете это сделать, но если вы это не успеете, то сделайте хотя бы простую пороговую модель и посмотрите, описывает ли она наблюдаемую сеть. То есть вы не успеете переучить сеть, хотя очень хочется, если честно. И можете скооперироваться с 7-м докладом Даши Гришиной. Вот эти вот propagation of COVID conspiracy theories, ну, на самом деле это тоже propagation. И у нее будут те же самые проблемы. То есть у нее датасет другой, и все-таки там идет, ну, как бы, но тема та же самая. У нее есть тренд, который люди усваивают. Только у нее тренд — это мировое правительство, а у вас цифровая трансформация. Ну, как бы вы делаете очень похожие вещи, и, скорее всего, одни и те же методы будут там хорошо работать. Поэтому я вам советую, ну, как минимум, там, пообщаться и как-то, ну, не знаю, держать руку на пульсе, потому что темы, вот где-то там, если абстрагироваться от данных, очень похожие. Как это не иронично, потому что, ну, буквально одни про теорию заговора, а вторые про усвоение инноваций. То есть как бы слова разные, а алгоритмы те же самые. Ну,
да, спасибо большое.
Правда, вот лучше потратьте время на правильный сетевой анализ, потому что с лингвистикой-то вы точно справитесь, там сложно ногу сломать. Но как бы, упущенное время может оказаться бесценным. Все, коллеги, 23:20, самый длинный семинар в нашем курсе благополучно завершен. Я всех выживших торжественно поздравляю с этим. Я, наверное, выложу запись, потому что, мне кажется, она там чудовищно эпичная. И в целом, мне кажется, что мы с вашей группой, правда, можем просто взять и организовать собственную секцию на какой-то конференции, где вы все то же самое, только уже доделанное, расскажете. Я, правда, очень впечатлен. Там, большей частью докладов я там регулярно рецензирую какие-то конференции, и, в общем-то, там половина докладов, которые мне присылают, по своей сути слабее, чем то, что я сейчас услышал. Мне прям было очень интересно и приятно вас послушать. Я надеюсь, что вы сейчас все-таки там не демотивируетесь полностью нашими бесконечными там разговорами, а, ну, правда, вот доделаете вот эти вот классные, интересные, содержательные проекты. В общем, тем, кто выжил, и тем, кто, может быть, мои там балабольства дослушает в записи когда-нибудь, я желаю удачи.
Спасибо. Спасибо, что всех нас дослушали, да. И что интересовались и давали фидбэк до конца.
Ну, у нас еще 4 спикера завтра.
Спасибо.
Да, но, тем не менее, там выжившим большой респект за то, что они тоже там досидели. Давайте, все, счастливо вам.
Да, все. До свидания.
До свидания, спасибо.